There is something about the ocean at night that resists understanding. Not the surface, the churning, wind-torn surface that sailors curse and fear, but what lies beneath it. The stillness down there. The pressure. The dark so complete it has weight. In that world, sound travels differently, time moves differently, and death arrives without announcement. During the Second World War, thousands of men climbed down into steel cylinders and descended into that darkness on purpose. They went to fight a war that no one on shore could see, in conditions that no training could fully prepare them for, with weapons that sometimes killed the enemy weeks after the men who deployed them were already back in port or already dead. This is the story of one of the most unusual weapons systems that war produced. Not a famous U-boat, not one of the sleek, fast attack boats that prowled the convoy lanes and whose commanders became household names in wartime Germany. This is the story of a different kind of submarine entirely, larger, slower, purpose-built for a mission that required patience over aggression, precision over speed, and a particular kind of nerve that is different from the nerve required to fire a torpedo at a ship you can see. This is the story of the Type 10 Germany's dedicated mine-laying submarine, a vessel designed from the keel up to plant invisible death in waters its crew would never linger in long enough to see disturbed. A boat whose kills, when they came silently, days or weeks after the mission was complete, in waters the enemy believed were safe. A weapon whose greatest achievement was the fear it generated in places it had never even been. Settle in. Find your comfortable position, because this story stretches across years and oceans, across drawing boards in secret offices and shipyards working under wartime blackout, across the freezing North Atlantic and the sheltered fjords of occupied Norway, across the careers of engineers, submariners, admirals, and the men on Allied vessels who never knew what had just struck the hull beneath their feet. It is a story with the patience built into it that the weapon itself required, and it rewards that patience. Before we go any further, if you are watching this for the first time, or if you found your way here through the long, quiet hours of the night, looking for something to keep you company while the world goes still, welcome. This channel exists for exactly that. Long-form history, told carefully, told completely, told in a way that is worth your time. Hit the subscribe button if you have not already, and consider turning on notifications, because there is a great deal more where this came from. The history of naval warfare in the Second World War runs deep, in every sense of that word, and we are only just beginning to explore it. Now, back to the bottom of the ocean. The Type 10 did not arrive from nowhere. It was the product of a chain of lessons stretching back decades to the mines that tore apart ships in the First World War, to the hard experience of submarine crews who learned what these weapons could do and what they could not, to the treaty negotiations that tried to contain German military ambition and instead merely drove it underground, sometimes quite literally. Every rivet in a Type 10 hull carried the weight of that history. Every design choice was an answer to a question that an earlier conflict had asked and left unanswered. Germany's U-boat arm in the Second World War is one of the most documented military forces in history, and yet the Type 10 occupies a strange space in that documentation. It was never numerous enough to dominate the historical narrative. Only a handful of these boats were ever completed and placed into service. But what they represent, strategically, technically, and humanly, is far larger than their numbers suggest. Think about what it means to lay a mine from a submarine. You are not firing a weapon at an enemy you can target. You are not engaging in a battle that will have a clear beginning and end. You are placing a trap. You are introducing uncertainty into a vast body of water. You are making a shipping lane dangerous, not just the lane you physically mine, but every lane the enemy now fears might also be mined. The psychological radius of a mine is far larger than its physical one, and when that mine is laid from a submarine that slipped in and out without detection, the uncertainty multiplies. The enemy cannot be sure where the submarine went, cannot be sure it will not return, cannot be sure which waters are now compromised. That is not just a weapon, that is a form of strategic pressure that costs relatively little to apply and forces the enemy to spend enormous resources to counter. The Kriegsmarine understood this. Their planners understood it in the 1930s when they began drawing up requirements for a vessel that could do this job at range, in depth, at scale. They understood it through 2 world wars and the years between them, when German naval doctrine was constrained by treaty, forced into secrecy, and yet quietly, methodically advanced by men who believed the next war was coming and intended to be ready for it. The Type 10 was their answer to a specific question: how do you bring the mine-laying mission into waters so dangerous, so well patrolled, so distant from German ports, that a surface mine layer could never survive long enough to do the job? You put the mines inside a submarine. You give that submarine the range to reach anywhere in the Atlantic approaches. You give it a crew trained for a mission that offers no glory, no confirmed kills, no dramatic sinkings, only the long, quiet work of positioning, releasing, and withdrawing before the enemy ever knows you are there. That is what these men signed up for. And that, in ways that only become clear when you trace the full arc of their operational history, is what makes their story worth telling at this length, at this pace, with this much care. There will be engineering in this documentary, because the engineering is genuinely extraordinary. There will be strategy, because the strategy is genuinely complex. There will be the human texture of life aboard these boats, because without that texture, the machines are just machines, and the history is just dates and tonnage figures. And there will be the other side, the Allied sailors and analysts and intelligence officers who spent years trying to understand, predict, and ultimately eliminate the threat these submarines represented. This is a complete history. From the earliest conceptual sketches to the last boats riding at anchor at the war's end, waiting to be assessed by the men who had been hunting them. All of it. All 18 chapters. Enough to carry you through a long night, or several of them if you let it run. The ocean is patient. The deep water keeps its secrets for a long time. But eventually, the full story surfaces. Let us begin. Before the first shot was fired on any European battlefield, before the columns of infantry crossed any border and the bombers climbed toward any city, the ocean was already a theatre of calculation. Admirals on both sides of the coming conflict had spent the interwar years studying the same brutal lesson that the First World War had written in the ledgers of sunken tonnage and civilian hunger. Whoever controlled the sea lanes controlled the war. For Britain, an island nation drawing the bulk of its food, fuel, and raw material from distant ports and distant continents, the sea was not simply a strategic asset. It was the condition of survival itself. Cut those lanes, and you did not merely wound the British war effort, you strangled it at the source before a single shell could be loaded into a single gun on any front that mattered. This understanding sat at the heart of German naval planning long before the September of 1939, and it shaped every decision the Kriegsmarine would make in the years that followed. Germany entered the Second World War at a profound disadvantage on the surface of the water. The Royal Navy outclassed the Kriegsmarine in capital ships, in cruisers, in destroyers, in virtually every category of vessel that conventional naval doctrine recognized as decisive. A surface engagement in the open North Atlantic was not a contest Germany could win, and the senior commanders of the Kriegsmarine understood this with cold clarity. But beneath the surface, the arithmetic shifted. A submarine could not be easily seen, tracked, or engaged by the overwhelming British surface superiority. It could travel submerged through contested waters, select its moment, strike without warning, and slip away before a proper response could be organized. The U-boat, that particular instrument of underwater war, offered Germany something the surface fleet never could: a means of projecting lethal force against British shipping that the Royal Navy's numerical advantage could not simply cancel out by showing up in greater numbers. It was asymmetric warfare before the phrase existed in any strategic vocabulary. The men who directed Germany's naval policy in the 1930s built their plans around this asymmetry with a conviction that bordered on faith. Grand Admiral Erich Raeder and, more specifically, for the submarine arm, Commodore Karl Dönitz believed that a sufficiently large fleet of U-boats, operating with discipline and coordination, could bring Britain to the negotiating table through economic strangulation alone. Dönitz, in particular, had calculated that sinking a sustained rate of Allied tonnage, month after month, would outpace Britain's capacity to build replacement vessels and recruit replacement crews. His logic was arithmetically defensible, even if it rested on assumptions about Allied industrial output and American neutrality that would eventually prove mistaken. At the start of the war, however, the U-boat campaign was not a desperate gamble. It was a considered strategic instrument, refined through years of theoretical development and quiet clandestine preparation. In the opening months of the war, the U-boats began their work with a success that alarmed Allied planners and heartened the Kriegsmarine. Merchant vessels went down in the western approaches, in the North Atlantic, in the waters around the British Isles. The convoys that Britain scrambled to organize were not yet well enough protected, the escort vessels not yet numerous enough, the detection technology not yet sophisticated enough to consistently locate and prosecute a submerged U-boat before it could strike and withdraw. German submariners developed tactical innovations, the Wolfpack, the night surface attack that further stretched the capacity of convoy escorts to defend their charges. Tonnage accumulated on the wrong side of the ledger with disturbing speed, and in London the men responsible for keeping Britain supplied watched those numbers with the particular anxiety that comes from watching a resource you cannot easily replace, being consumed faster than you can generate it. The Type 7 U-boat was the workhorse of this campaign. Compact, maneuverable, produced in numbers that no other single class of U-boat would match, the Type 7 was the instrument through which Dönitz prosecuted the Battle of the Atlantic. It was a weapons platform designed around the torpedo, the direct, aggressive, visible in its consequence attack that defined most people's understanding of submarine warfare. A torpedo fired from a U-boat produced a specific result in a specific place at a specific time. The crew knew whether they had struck. They heard the detonation, they saw the vessel list, they could confirm the kill. The psychology of this kind of warfare was brutal, but it was at least legible. You aimed, you fired, you knew. The operational feedback loop was short, and success or failure declared itself quickly enough to shape the next decision. But the torpedo was not the only way a submarine could kill. And as the Kriegsmarine's planners looked at the full geography of the war at sea, they identified waters where the torpedo-armed U-boat could not easily reach, or could not easily survive long enough to operate effectively. Harbour approaches, shallow coastal lanes, heavily patrolled choke points where the volume of Allied anti-submarine activity made sustained surface or shallow operations extraordinarily dangerous. These were precisely the waters through which the most critical Allied shipping had to pass into Liverpool, into Bristol, into the Thames estuary, into the ports on which Britain's entire resupply apparatus depended. A conventional U-boat could not linger in those waters hunting individual ships without attracting the kind of concentrated Allied attention that made survival a serious question. Something else was needed. A weapon that did not require the submarine to remain in the area after it had been deployed. A weapon that could do its work long after the vessel that delivered it had slipped silently away. The naval mine answered that description with a precision no other weapon could match. Laid covertly in a shipping lane or harbour approach, a mine did not announce its presence. It waited. It exercised what naval strategists would later call area denial, converting a section of water from a passage into a hazard, forcing the enemy to spend time, resources, and expertise simply to make a route safe enough to use. A single minefield, well placed, could disrupt convoy scheduling, redirect traffic into less efficient routes, tie up minesweeping vessels that might otherwise be protecting other waters, and occasionally produce the sudden, catastrophic detonation that announced the mine's presence by destroying a ship. The mine was patient in a way no crew could afford to be. It did not need to be fed, rested, or relieved. It simply waited for physics to do what strategy had arranged. The Kriegsmarine's planners understood this, and they also understood something more specific, that delivering mines covertly into defended waters required a vessel with particular qualities that none of the existing U-boat classes could fully satisfy. The Type 7 was too small to carry mines in sufficient quantity to make a covert delivery mission worth the risk of the approach. Surface mine layers, the conventional answer in earlier conflicts, were hopelessly vulnerable to the air and sea patrols that Britain maintained around its home waters by the early years of the war. What was needed was a submarine large enough to carry a militarily meaningful number of mines, with the range to reach distant targets and return, and with the specific engineering to deploy those mines accurately and reliably while submerged or under the cover of darkness, without surfacing into waters where Allied patrol vessels might be waiting. A vessel designed from first principles for this specific mission, rather than adapted from a design meant for something else. This was not an insight that arrived suddenly during the war. The Kriegsmarine had identified this operational requirement years before the fighting began, in the careful deliberations of naval planners who had studied the mine-laying submarine campaigns of the First World War and drawn their conclusions methodically. The need was documented, the specifications argued over, the design philosophy debated before a single keel was laid. What emerged from that process was a vessel that would become the largest submarine class Germany built during the Second World War, a boat designed not to hunt ships in the direct, aggressive fashion of its torpedo-armed cousins, but to seed the ocean floor with silent, patient killers and then vanish, leaving the consequences to accumulate in waters its crew would never see again. The Type X mine-laying submarine was, in this sense, a weapon built entirely around an idea rather than around a moment of combat. Its purpose was not the dramatic instant of a torpedo strike. Its purpose was the slow, invisible pressure of threat, the corrosion of Allied confidence in waters that had been declared safe, the vast diversion of resources into minesweeping operations, the rerouting of convoys that cost time and fuel, and ultimately tonnage as ships were forced away from the shortest lines between 2 points. It was a weapon of strategic patience in a war that would eventually be decided by which side could sustain the most for the longest time at the greatest cost. Understanding why Germany built it requires understanding the full weight of that calculus, not just how the war was being fought on any given day, but how each side was trying to make the other's position structurally, irreversibly untenable over months and years. The Type X was Germany's answer to a question the ocean itself had posed. Whether that answer would be sufficient was a question the war would answer with its own terrible arithmetic. There is a particular kind of fear that belongs only to the sea, not the fear of a shell you can hear whistling overhead or a torpedo whose white wake gives you a few desperate seconds to react. This fear is older and quieter. It lives in the water itself, in the knowledge that what floats beneath the surface cannot be seen, cannot be heard, and announces itself only at the moment it is already too late. Before the Type X ever left a German shipyard, before a single engineer drew a line on a blueprint for the boat that would carry them, the mine had already spent a century proving itself as one of the most psychologically devastating weapons ever deployed at sea. To understand why Germany needed a submarine designed specifically to lay mines in secret, you first have to understand what made the mine so worth deploying secretly in the first place. The naval mine as a weapon traces its roots further back than most people expect. As far back as the American Civil War, improvised explosive devices were being anchored to harbor approaches to deny enemy vessels safe passage. They were called torpedoes, then a word that would eventually migrate to an entirely different weapon, and their early versions were crude. Wooden casks packed with black powder, connected to a firing mechanism that might work or might not, depending on whether the salt water had already found its way inside. Yet even in that primitive form, the principle was sound and the effect was real. A vessel could be stopped not by defeating it in open battle, but by making the water itself dangerous. That insight, once established, never left naval thinking. It deepened, refined itself, and by the time the First World War arrived, it had grown into something formidably sophisticated. The most widespread mine of the early industrial era was the contact mine, and in its moored form it became the defining image of the weapon class for generations of sailors. The design was deceptively straightforward, a steel sphere, roughly the size of a large barrel, packed with explosive and bristling with protruding horns made of a soft metal. The sphere sat below the surface, held at a specific depth by a wire cable anchored to a weight on the seabed. When the hull of a ship brushed against one of those horns and crushed it, a glass vial of acid inside the horn would break. The acid would complete an electrical circuit, and the explosion that followed could tear open the belly of a warship with a violence that owed nothing to aim and everything to geometry. You did not need to be a skilled gunner. You did not need line of sight, wind conditions, or ammunition supply. You needed only to have placed the mine where the enemy was going to be. This quality, the displacement of effort from the moment of attack to the moment of placement, was what made naval mining so strategically significant. A minefield did not require a crew to be present when it killed. Once laid, it worked continuously, patiently, in the dark, until every ship in the target area had either been struck or rerouted around it. 100 mines placed at the mouth of a major harbour could bottle up an entire fleet or force the rerouting of convoys across distances that added days to every voyage and multiplied the fuel, wear, and exposure of every ship involved. The mine was, in the clearest possible sense, a force multiplier, a relatively small investment in hardware and placement effort that paid strategic dividends for weeks or months after the laying operation was complete. By the time of the First World War, the naval powers of Europe were deploying mines by the hundreds of thousands. The North Sea became one of the most densely mined bodies of water in history. Both Britain and Germany laid enormous defensive and offensive barrages, some of them stretching across vast stretches of open ocean. The Great Northern Barrage, a joint Allied effort to seal off the passage between Scotland and Norway, consumed a staggering number of mines and represented an engineering undertaking of almost industrial proportion. The Kriegsmarine's predecessor, the Imperial German Navy, watched these efforts closely and learned from both their successes and their failures. They noted which mine types proved most effective, how quickly enemy forces adapted their routing in response, and critically, how difficult it was to keep a major mine-laying operation secret when it was conducted by surface vessels that were visible and identifiable. This last lesson mattered enormously. A surface mine layer, a converted merchant vessel, or a dedicated naval ship was a detectable asset. It could be spotted by patrol aircraft, intercepted by destroyers, or tracked by intelligence networks watching port movements. The moment your enemy knew you had laid mines in a particular area, the strategic value of those mines began to decay. Minesweepers were dispatched. Convoys were rerouted. The element of surprise, which was a mine's most powerful force multiplier, was squandered the moment the ship that carried them was identified. The solution, in theory, was obvious. Lay the mines from a vessel that could not be seen. A vessel that could slip beneath the surface, navigate to a target area under cover of total invisibility, release its weapons, and return to port without anyone knowing it had ever been there. The solution, in other words, was a submarine. But the mine itself was also evolving, and that evolution was adding entirely new dimensions of lethality to an already formidable weapon. The contact mine, for all its effectiveness, had a vulnerability. It could be swept. A pair of ships towing a wire between them could cut the mooring cables of contact mines, causing them to float to the surface where they could be detonated safely. It was painstaking, dangerous work, but it was work that naval forces around the world had learned to do with increasing efficiency. The mine designers responded by developing mines that could not be swept in the conventional sense. The magnetic mine was one of the most consequential weapons to emerge from this arms race between the mine layer and the minesweeper. The magnetic mine sat on the seabed rather than hanging from a mooring wire. It carried a sensor that detected the change in the local magnetic field caused by a steel-hulled ship passing overhead. When that disturbance reached a preset threshold, the mine detonated. Because it rested on the bottom, the traditional wire sweep was useless against it. Because it detonated beneath the hull rather than at the waterline, the explosion pattern was different, more likely to break a ship's keel than simply punch a hole in her side, with correspondingly catastrophic results. When Germany began deploying magnetic mines in the early years of the Second World War, the effect on Allied shipping was severe and immediate. Ships were being lost in waters that had been swept and declared safe. The The cause was unknown long enough to generate genuine alarm in British naval circles, until engineers managed to recover an example of the new weapon and begin developing countermeasures. Those countermeasures came in the form of degaussing, a process by which a ship's steel hull was fitted with electrical cables that generated a magnetic field, neutralizing the ship's own magnetic signature. It was an effective solution, and eventually most Allied vessels were equipped with it. But the cycle did not stop. The acoustic mine followed, a weapon that used a hydrophone to detect the distinctive noise signature produced by a ship's propellers and machinery, trigger a specific frequency, and the mine fired. Countermeasures for acoustic mines required ships to reduce underwater noise output, to slow down in suspected areas, and eventually to use specialized equipment that mimicked the acoustic signature to detonate mines at a safe distance ahead of the vessel. Every new mine type forced the development of a new countermeasure, and every new countermeasure prompted the development of a new mine type. This cycle consumed enormous Allied resources throughout the war, in engineering effort, in ship-fitting time, and in the sheer manpower required to keep the minesweeping fleets operational. The psychological dimension of mine warfare should not be underestimated. A torpedo leaves a wake. A gun announces itself with sound and flash. A bomb arrives from a visible sky. A mine gives no warning whatsoever. For the crews of Allied merchant ships and naval vessels, sailing through waters where mines might be present meant living in a state of suspended dread that no amount of professional discipline could entirely suppress. Every change in the ship's motion, every unusual sound transmitted through the hull, every dark shape glimpsed in the water carried the possibility of being the last thing a crew member would ever perceive. This dread was not irrational, it was a precise calibration of real risk. Ships were lost in waters that had been swept. Ships were lost in waters that had never been suspected. The mine was a weapon that made certainty impossible, and uncertainty, sustained over months and years, was itself a form of attrition. It was this combination of properties, strategic reach, delayed effect, psychological impact, and the paralyzing difficulty of countermeasures that made the mine so attractive to German naval planners working on the problem of Atlantic interdiction. The weapon could do things that no other weapon could do. It could deny an enemy the use of a harbour for days or weeks. It could force the rerouting of entire convoy networks. It could kill ships that never knew they were in a fight. And it could do all of this while the crew that deployed it was already hundreds of kilometers away, safely submerged, leaving no trace of their passage. The mine was not a blunt instrument. In the right hands, delivered to the right place by the right vessel, it was a scalpel, precise, patient, and devastatingly effective. What the Kriegsmarine needed was a submarine large enough to carry enough of these weapons to matter, long-ranged enough to reach the waters where they would do the most damage, and capable of operating in conditions that would deny any surface vessel safe passage. What they needed, in other words, was the Type X. The First World War did not end at the surface. Beneath the grey chop of the North Sea and along the shipping lanes that fed the British Isles, another war had been fought in silence, one that left lessons buried so deep in the institutional memory of German naval, thinking that they would take 2 decades to fully surface. When German planners in the 1930s began sketching the requirements for what would become the Type X, they were not working from imagination alone. They were working from a ledger of hard experience, a record of things tried and things broken, of mines that sank ships and submarines that never came home. That ledger had been written in the First World War, and every entry in it mattered. Germany had entered the First World War with a U-boat fleet that was, by any honest measure, a work in progress. The technology was young, the doctrine half-formed, and the strategic possibilities not yet fully understood by the admirals who commanded the surface fleet and regarded submarines with a mixture of interest and mild contempt. But the mine was already a proven weapon, and the logic of combining the mine with the submarine putting the weapon where the enemy could not see it being laid had already begun to attract serious naval attention. The earliest German mine-laying submarines were converted torpedo boats, standard hulls adapted to carry mines in place of some of their usual armament. They were imperfect solutions, but they pointed towards something important. The idea that a submarine could reach waters a surface mine layer never could, and lay its cargo without being seen. Among the earliest lessons was one about vulnerability. Surface mine layers had been employed by both sides from the war's opening months, and their limitations were immediately apparent. A surface vessel approaching an enemy coastline or a busy shipping lane to scatter mines did so in daylight, subject to detection by patrol craft, coastal observation posts, and eventually aircraft. The moment of mine laying was also the moment of maximum danger. A submarine, by contrast, could approach submerged, lay its mines under cover of darkness or below the waterline entirely, and withdraw before any defender knew it had been there. The value of this was not theoretical, it was demonstrated in operational results that German naval intelligence tracked with careful attention throughout the war. Where surface mine layers were turned back or sunk, submarines often succeeded. The converted German mine-laying submarines of the war years achieved results that validated the concept while simultaneously exposing the limits of improvised design. They operated in the North Sea approaches, in the waters around the British Isles, and in some cases further afield, sowing minefields that Allied shipping subsequently struck with costly results. Ships went down in waters that had been surveyed and considered reasonably safe. Port approaches had to be swept repeatedly. Convoy routing became more complex. The disruption was real and measurable. But the submarines delivering these results were doing so despite their design, not because of it. Mine capacity was limited by the fact that internal space was shared with torpedo equipment, crew quarters, and machinery that could not simply be removed. Endurance was constrained. The boats that could carry the most mines were often the most uncomfortable to crew and the most sluggish to handle. One of the most significant developments of the later war years was the attempt to build submarines designed from the keel up as mine layers rather than adapted from existing hulls. German naval engineers explored configurations in which mines could be stored and deployed from dedicated tubes or shafts built into the hull rather than loaded into repurposed spaces. These designs represented a genuine conceptual advance, separating the mine-laying function from the torpedo function and allowing each to be optimized independently. The results were mixed in practice. The engineering was difficult, the timelines stretched by the pressures of wartime production, and some promising designs never reached operational service in meaningful numbers before the armistice. But the thinking behind them did not disappear when the war ended. It went into files, into technical reports, into the memories of the men who had worked on those designs, and who would, in some cases, still be working in naval engineering circles a decade later. Endurance was another lesson that the First World War wrote in stark terms. The mine-laying mission had a different rhythm from the torpedo attack. A torpedo boat or a standard attack submarine could hunt and strike within a relatively contained patrol area. A mine layer, by contrast, needed to reach specific locations often far from base, often in heavily patrolled waters, lay its mines with precision, and then return safely. The further the target area, the longer the patrol. The longer the patrol, the more diesel fuel required. The more diesel fuel, the less internal space for crew supplies, spare parts, and the mines themselves. German submariners who had conducted long mine-laying patrols in the First World War understood this tension in their bones. Fuel endurance and mine capacity were locked in a zero-sum struggle, and any future design would have to find a way to break that constraint rather than simply accept it. Crew endurance was a companion problem that received less attention in official reports, but lived vividly in the experience of the men who served. The mine-laying submarine was not a quick-strike weapon. Its patrols were long, its missions required patience and precision rather than speed and aggression, and the psychological character of the work was unusual. A crew might lay mines and never know for weeks or months whether any of them had found a target. The confirmation of success, when it came, arrived through intelligence reports and newspaper accounts rather than through the immediate, visceral feedback of a torpedo detonation. This distance between action and consequence placed a particular kind of pressure on men who had volunteered for submarine service because they wanted to fight. Naval planners noted the importance of crew morale on long patrols and the need to select and train men specifically suited to the mine-laying role, an insight that would inform crew selection protocols for the Type X a generation later. The post-war accounting also forced German naval thinkers to confront what had not worked. Some mine-laying patrols had been compromised before the mines could even be laid, either through navigational error that placed mines in the wrong location, or through detection by Allied forces that forced the submarine to abort and withdraw. Precision navigation in confined or unfamiliar waters was genuinely difficult under wartime conditions, and the consequences of error were severe. Mines laid in the wrong position wasted the patrol entirely, while mines laid too close to neutral shipping lanes risked diplomatic disasters Germany could not afford. The lesson was clear. A mine-laying submarine was only as useful as the accuracy with which it could position itself and its weapons. Navigation equipment, training, and charts all mattered enormously. Future design would have to take this seriously. The Treaty of Versailles, signed in 1919, was intended to close the book on German naval ambition. Germany was stripped of its submarine fleet, prohibited from building new submarines, and left with a rump surface navy that the victorious powers calculated was insufficient for offensive war. What the treaty could not strip away was knowledge. The engineers, officers, and technical staff who had designed, built, and operated Germany's First World War U-boats did not simply disappear. Some retired, some moved into civilian engineering. Others remained within the structures of the German Navy, which survived as the Kriegsmarine, formally constrained but institutionally intact. The knowledge they carried about hull design, mine-laying mechanics, crew endurance, and the operational logic of covert mine-laying was preserved in technical archives and in the professional culture of men who still talked to one another, still attended the same clubs and professional associations, and still thought about submarines even when they were forbidden to build them. What the Kriegsmarine did with those years of enforced inactivity was, in some respects, more productive than open development would have been. Constrained from building, German naval thinkers were forced to think more carefully than they might otherwise have done. The requirements for a future mine-laying submarine were worked over in theoretical papers, in informal discussions, and in the studies that found their way into the thinking of naval architects who would later be cleared to act on them. The key conclusions solidified over time that a future mine layer must carry far more mines than any First World War design had managed, that it must have the range to reach distant target areas without refueling, that its mines must be stored and deployed in a way that did not compromise crew habitability or mechanical reliability, and that the entire system must be operable in conditions of complete secrecy, no surfacing, no signals, no trace that could be read by an enemy patrol. By the time Germany began its covert rearmament in the late 1920s and early 1930s, these conclusions had hardened from lessons into requirements. The men writing the new design specifications were not starting fresh. They were translating 2 decades of accumulated thought born from the hard experience of the First World War into engineering language. Every design choice they would make was shadowed by what had been learned between 1914 and 1918. The external mine shafts that would become the defining feature of the Type X, the emphasis on long-range diesel capacity, the particular attention to crew quarters on a submarine far larger than standard practice demanded, none of these emerged from pure invention. They emerged from memory. The First World War had been the laboratory. The interwar period had been the analysis. What came next was the building. The guns fell silent in November of 1918, but the war Germany intended to fight next had already begun to take shape in the minds of its naval officers. Defeat had stripped the country of its fleet, its overseas territories, and much of its national pride, but it had not stripped its admirals of memory. Those men remembered what submarines had very nearly accomplished, remembered how close the undersea campaign had come to severing Britain's lifeline entirely, and they were not prepared to surrender that knowledge along with the ships themselves. The Treaty of Versailles was explicit and severe in its terms. Germany was forbidden from building or possessing submarines of any kind. The Kriegsmarine, the small, hobbled navy permitted to the defeated nation, was to be a coastal defense force in name and in reality. Yet within years of the ink drying on those pages, a quiet and determined effort was already underway to ensure that when the restrictions eventually lifted or were discarded, German submarine engineering would not have spent the intervening years standing still. The mechanism Germany used to circumvent Versailles was not crude deception, but rather something far more elegant: the construction of an entire parallel industry at arm's length from the German state. In 1922, a technical bureau was established in the Netherlands, ostensibly a private commercial enterprise with no formal connection to the German government. The firm went by the name Ingenieurskantor voor Scheepsbouw, though it was known in naval circles simply by its initials. Its purpose, carefully obscured beneath the language of civilian naval consulting, was to keep German submarine design alive, to employ the engineers who had built the U-boats of the previous war and ensure their expertise did not disperse into peacetime obscurity. The Dutch cover was convincing enough on the surface, but the work being done was unmistakably military in character. Submarine designs were drawn, debated, refined, and filed away. Hull forms were modelled, diving systems were theorized, the knowledge accumulated quietly, like sediment settling into stone. This bureau did not work in isolation. Through the 1920s, Germany leveraged its engineering reputation to secure contracts with several foreign navies, each contract serving the dual purpose of generating revenue and providing a living laboratory for submarine concepts that could never be tested openly on German soil. Finland received a submarine, Turkey received one. Spain received technical assistance. Each project fed data back into the growing archive of German submarine knowledge, allowing engineers to test ideas about hull strength, propulsion efficiency, diving depth, and endurance against the hard reality of construction and sea trials. These were not experimental toys. They were working submarines, built to genuine operational standards, and the lessons extracted from them were treated with the same rigor Germany applied to any serious military program. By the time the 1920s gave way to the 30s, the men who would eventually design the Type X had already accumulated years of practical experience through this network of foreign proxies. Within the Kriegsmarine itself, a small cadre of officers was engaged in a parallel intellectual exercise, wargaming the submarine campaigns of the future, studying what the previous war had demonstrated, and drawing up requirements for the vessels they believed would be needed. These officers were constrained by law from saying too much openly, and they were careful about documentation, but they thought and planned with great specificity. Among the requirements that emerged from these discussions was a persistent concern about mine laying, about the need to place mines in waters where surface vessels could not go without being destroyed, in harbours approaches and river mouths and coastal shipping lanes that Allied navies would guard heavily from the first day of any future conflict. A submarine that could slip beneath those defences and seed those waters with mines was a capability the Reichsmarine wanted urgently, and one it was quietly determined to possess. The conceptual challenge was considerable. Mine-laying submarines had existed during the First World War, but they had been vessels of compromised design boats whose torpedo armament was sacrificed or reduced to accommodate mine storage. Boats that were cramped and short-ranged, boats that carried too few mines to justify the operational risk of deploying them. What the Reichsmarine's planners envisioned was something fundamentally different. A dedicated mine layer, large enough to carry a truly significant number of mines, with the range to reach distant waters and the endurance to wait for the right conditions before deploying. It would not be a compromise. It would be a purpose-built instrument designed to do one thing exceptionally well, across the widest possible operating area. Writing that requirement down was the easy part. The engineering problems it created were another matter entirely. When Adolf Hitler came to power in January of 1933, the pace of naval rearmament accelerated dramatically. Though it remained cautious and incremental at first, still nominally bound by treaty commitments that Germany had not yet formally renounced. The naval budget expanded. Contact between the Foreign Design Bureau and German naval authorities became closer and less discreet. Engineers who had spent years working through Dutch front companies began to return to Germany proper, carrying their accumulated knowledge with them. The Submarine Design Office, long a ghost institution existing only in careful paperwork and foreign workshops, began to acquire something like a physical home. Planning moved from the theoretical to the practical, from the question of what kind of submarine was wanted to the harder question of how exactly it was going to be built. By 1935, Germany was done pretending. The Anglo-German naval agreement of that year granted Germany the right to build a submarine fleet up to 35% of British tonnage, and with that agreement came the formal re-establishment of German submarine development as an open program rather than a clandestine one. The officers and engineers who had spent years working in shadow could now work in daylight. Design specifications that had existed as unofficial documents were formalized. Requirements that had been discussed in careful, deniable language were codified into proper naval requirements. The submarine type that would become the Type X was at this point still an evolving specification rather than a fixed design, but its core requirements, large displacement, long range, heavy mine capacity, ocean-going capability, were already firmly established in the minds of the men who would build it. The lead engineer responsible for bringing the Type X concept into formal specification was a figure steeped in the accumulated expertise of the interwar period, a man whose professional life had been spent thinking about submarines at a time when Germany was forbidden from having them. The design challenge he faced was not purely technical, but also political and logistical. The boat had to be large enough to carry the mine load the Kriegsmarine required, yet it had to be buildable within the constraints of German shipyard capacity, which was simultaneously being stretched by the demands of surface warship construction. Every choice made on the drawing board had downstream consequences for the shipyards, for the supply chains, for the training institutions that would have to produce crews capable of operating the most complex submarine Germany had ever attempted. One of the most significant design decisions made during this specification phase concerned the arrangement of the mines themselves. Storing mines internally inside the pressure hull alongside the crew created enormous problems of space, safety, and operational flexibility. The alternative that emerged from the design discussions was to build the mines into external shafts within the boat's saddle tanks, launching them from outside the pressure hull entirely. This approach had precedent in earlier German minelaying designs, but the scale at which the Type X would apply it was unprecedented. It allowed the boat to carry a far larger number of mines without sacrificing internal volume to the weapon, preserving space for the fuel, provisions, and machinery that a long-range ocean-going submarine required. The engineering consequences of this decision would shape virtually every other aspect of the Type X's design, from its hull diameter to its ballast arrangements. The secrecy of the interwar years had shaped German engineering in ways that were not always visible from the outside. Working through foreign front companies and proxy contracts had forced German engineers to be exceptionally precise in their documentation, because their designs had to be transmissible across national borders without the kind of direct, in-person coordination that domestic programs allowed. This enforced precision created habits of rigor that carried over into the formal design phase. The specifications produced for the Type X were detailed and systematic in a way that reflected years of careful, circumspect engineering practice. Every dimension, every load calculation, every operational parameter was documented with a thoroughness born of working in an environment where ambiguity could not be tolerated. As the 1930s advanced and the formal design of the Type X moved closer to its final form, the men involved understood that they were building something whose deployment was a matter of when rather than if. The political trajectory of Germany in those years made the purpose of their work unmistakable. These were not engineers working in abstract service of naval theory. They were building a weapon for a war that their leadership was actively preparing. The moral weight of that knowledge sits differently across the distance of history than it may have sat in the engineering offices of Hamburg or Kiel in 1937, but it is part of the story nonetheless, the human layer beneath the technical one, the faces behind the blueprints. The Type X was conceived in secrecy, gestated in careful deception, and born into a world that was already accelerating toward catastrophe. By the time the formal specification was handed to the shipyards, the war it was designed for was barely 2 years away. By the early 1930s, the men tasked with designing Germany's next generation of naval weapons understood something that most politicians preferred not to admit openly. The future war at sea would be won or lost, not on the surface, but beneath it. The submarine had proven itself in the last conflict as a weapon capable of bringing an empire to its knees. Now the question was not whether to build more U-boats, but what kind and for what specific purpose. The mine-laying requirement sat at the intersection of two strategic imperatives: the need to strike at Allied shipping without exposing German vessels to counterattack, and the need to hold vast stretches of ocean at risk, using a weapon that asked nothing of the submarine after deployment. A mine, once placed, worked on its own terms, in its own time. What the Kriegsmarine needed was a boat large enough and robust enough to carry those mines in meaningful numbers to waters that no surface vessel could safely reach. The design that would eventually emerge was not born in a single moment of inspiration. It was built, painfully and methodically, from a foundation of competing demands that no simple solution could reconcile. The fundamental problem facing the engineering teams was one of scale. Every submarine design begins as an argument between what the operator wants and what the ocean will allow. The Kriegsmarine's requirements for a dedicated mine-laying submarine were, by any measure, ambitious to the point of being daunting. The boat had to carry a large number of mines, not the modest loads that earlier improvised designs had attempted, but a payload substantial enough to justify the cost and risk of a long ocean passage. It had to operate at extreme range, reaching distant waters and returning without resupply. It had to be capable of sustained underwater operations in heavily patrolled areas, which demanded reliability in every mechanical system. And it had to provide adequate habitability for a crew large enough to manage all of these functions across patrols that could stretch for weeks. Each of these requirements, taken alone, could be met. Meeting all of them simultaneously within a single pressure hull was an engineering problem of genuine difficulty. The displacement question was the first domino. A boat large enough to carry the required mine load would, by definition, be heavy. Greater displacement meant greater surface area, which meant greater drag, which meant either reduced speed or more powerful and heavier propulsion. Heavier propulsion demanded more fuel, which added further displacement. The spiral was familiar to any naval architect, but the Type X pushed it to extremes not previously encountered in German submarine design. The engineering bureaus working on the project operating under layers of institutional secrecy even as Germany's official posture toward Versailles began to harden, ran iteration after iteration of displacement. Calculations, trying to find a configuration that did not collapse under its own requirements. The hull length grew, the beam grew, and with each revision, the question of where to put the mines became more pressing, not less. Internal stowage was the obvious answer, and it was explored seriously. Earlier mine-laying submarines, including those Germany had operated in the First World War, had carried their mines in internal tubes or modified torpedo spaces. The logic was sound. Internal stowage protected the mines from the mechanical stresses of open water, kept the hull's hydrodynamic profile clean, and simplified loading and deployment. But internal stowage imposed hard limits on capacity. Every mine stored inside the pressure hull displaced space that could otherwise be used for fuel, provisions, or crew accommodation. On a boat already struggling to balance its weight budget, devoting large internal volumes to mines was a trade-off that quickly became untenable. The numbers simply did not work. If the Type X was to carry the mine load the Kriegsmarine required, the mines could not live inside the hull. The solution that emerged was as elegant as it was unconventional. The Type X would carry the majority of its mines not inside the pressure hull, but in dedicated vertical shafts built into the saddle tanks, the large, external buoyancy structures that wrapped around the outside of the main hull on either side. These saddle tanks were a feature of many large submarine designs, serving primarily to provide reserve buoyancy and fuel storage. On the Type X, They were reimagined as a mine magazine. Each shaft ran vertically through the saddle tank structure, opening at the keel, and was designed to hold a single mine that could be released when the boat was submerged and positioned over the target area. By distributing these shafts along both sides of the hull in multiple banks, the designers achieved a mine capacity that would have been impossible through any internal arrangement. The mines dropped away beneath the boat by gravity and the careful management of pressure, settling toward the seabed in a pattern determined by the submarine's track and speed. This external shaft arrangement solved the capacity problem, but it introduced new ones. The shafts themselves had to be engineered to withstand the full range of pressures encountered during a diving cycle, from the crush of depth to the atmospheric transition of surfacing. Each shaft was essentially a separate pressure vessel, integrated into the saddle tank structure but mechanically distinct from the main hull. The seals and release mechanisms had to function reliably in cold water, under pressure, operated by men working in confined spaces with limited visibility and considerable psychological stress. A mine that failed to release at the correct moment was an embarrassment. A mine that released at the wrong moment was a catastrophe. The engineering tolerances demanded were extraordinarily tight, and the iterative process of refining the shaft design consumed months of bureau effort and considerable quantities of steel in prototype testing. The propulsion arrangement for a boat of this size presented its own set of challenges. The Type X required diesel engines capable of driving a vessel of several hundred tons, displacement across thousands of nautical miles, and electric motors powerful enough to maintain meaningful submerged speeds during the approach and withdrawal phases of a mine-laying run. The fuel load required to achieve the desired range was enormous, and fuel stowage competed directly with mine stowage and crew space in the overall volume budget. The designers allocated fuel not only in the standard internal tanks, but in the saddle tank spaces not occupied by mine shafts, threading every available void with storage capacity in an effort to push the boat's range to the operational limits the Kriegsmarine demanded. The result was a vessel that, fully loaded, carried an almost bewildering quantity of different stores in a carefully balanced arrangement that left very little margin for error. Crew habitability was, in the hierarchy of engineering priorities, ranked below range and mine capacity, but it could not be ignored entirely. A crew too exhausted or too physically deteriorated to operate the boat was as dangerous as a mechanical failure. The Type X, being substantially larger than the standard attack U-boats of the period, offered more internal volume than its smaller fleet cousins, and the designers made reasonable efforts to provide sleeping accommodation, a functional galley, and adequate sanitary facilities for the expanded complement. But the presence of the saddle tank shaft systems, the additional fuel tankage, and the more complex electrical and mechanical systems meant that the internal arrangement was dense and in places genuinely cramped despite the boat's overall size. Officers fared better than enlisted men, as was universal in naval design of the period. The enlisted crew shared bunks in rotation, ate in shifts, and conducted their daily lives in a space that was, by any civilian measure, extraordinarily confined. The command and control arrangements aboard the Type X reflected the complexity of its dual mission. Unlike a standard attack boat, which could be managed by a relatively straightforward command structure oriented around torpedo attack, the Type X had to coordinate mine-laying runs that required precise navigation, careful depth management, and the synchronization of mine release with the boat's track across the target area. The commanding officer needed to know not just where the boat was, but where it would be at each moment of the deployment sequence, so that the mines fell into a pattern that would achieve the intended area denial effect, rather than clustering uselessly in a single location. This placed considerable demands on the navigation team and on the accuracy of the boat's instruments, which the designers addressed through the installation of the best available dead reckoning equipment and, where possible, optical systems usable from shallow depth. The iterative refinement of the design extended to the boat's external profile and its surfaced handling characteristics. A vessel the size of the Type X had to be manageable in the often rough conditions of the North Sea and North Atlantic, and the saddle tanks, while essential to the mine-carrying concept, created a hull form that behaved differently from a conventional submarine when running on the surface in heavy weather. The designers modeled wave behavior against the saddle tank geometry and made several adjustments to the tank profiles and the forward hull form to reduce the worst of the pitching and rolling that early configurations produced in simulated sea states. These were not glamorous refinements, they showed up in no public statement and attracted no public attention. But they were the kind of painstaking work that determined whether a design that looked correct on paper actually functioned in the hands of men at sea. By the time the design approached its final form, the engineering bureaus had produced a specification for a boat that was, by any measure, remarkable in scope. The displacement figures placed the Type X in a category of its own within the German submarine program. The mine capacity exceeded anything previously achieved in a submarine design of any navy. The range, while not unlimited, was sufficient to reach waters that had never before been seriously threatened by covert mine-laying operations. And the crew complement, though larger than any standard U-boat, had been accommodated within a hull arrangement that, if not comfortable, was at least survivable across the extended patrols the boat's designers envisioned. What remained was to translate that specification into steel, to take the weight calculations and the drawing board geometries and the carefully balanced volume budgets and turn them into an actual submarine that would have to work under pressure in water that did not forgive mistakes. That transition from blueprint to breathing machine would prove to have its own set of revelations. When the pencils were finally set down and the technical drawings rolled into their protective cases, the real work began. The specifications that German naval architects had labored over through years of careful iteration now had to be translated into something altogether more demanding than lines on paper. They had to be translated into steel. The yards selected for this work were among the most capable in Germany, facilities with long traditions of building complex naval vessels and workforces, schooled in the particular discipline that submarine construction demands. These were not places where improvisation was tolerated. Every measurement had to be exact, every weld inspected, every pressure hull section tested against the crushing weight of the depths the boats would eventually be asked to reach. The transition from blueprint to physical structure carried with it a kind of institutional gravity. The knowledge that errors made in a shipyard office or on a fabrication floor might not reveal themselves until a boat and its crew were far beneath the surface of a hostile sea. Construction of the Type X boats began in earnest in the middle years of the 1930s, at a moment when Germany's relationship with its own rearmament was shifting from whispered concealment to open defiance. The Anglo-German Naval Agreement of 1935 had lifted the formal ceiling on German submarine tonnage in exchange for a negotiated limit relative to British naval strength, and the Kriegsmarine moved quickly to exploit the room this created. Yet even as public restrictions fell away, a culture of deliberate opacity clung to these projects. The sheer scale of what was being built attracted attention, and the Kriegsmarine had no interest in advertising either its mine-laying ambitions or the specific technical solutions its engineers had devised. Information about the external mineshaft arrangement, the saddle tank configuration, and the boat's true operational radius was treated as closely held knowledge, shared only among those whose work made it strictly necessary. The hulls themselves were enormous by the standards of submarine construction then current anywhere in the world. The Type X displaced well over 2,000 tons when surfaced, making each boat a substantial industrial undertaking, requiring quantities of high-grade steel that had to be sourced, cut, formed, and certified with precision. Fabrication happened in sections, the pressure hull divided into manageable segments that could be assembled in sequence, tested individually, then joined with the kind of care that left no tolerance for compromise. Workers who had spent their careers building surface vessels had to adapt their instincts to a discipline where the margin for structural error was measured not in inconvenience, but in catastrophe. The foreman who supervised this work carried the particular quiet intensity of men who understood exactly what they were building and for whom. The fitting out process that followed the hull's initial completion was where the Type X's most distinctive features took shape in physical form. The external mine shafts sunk into the saddle tanks, that defining engineering decision made during the design phase to maximize mine capacity without compromising the pressure hull, had to be installed with meticulous care. Each shaft had to be watertight under operational pressure, mechanically reliable enough to deploy mines in sequence during a darkened, tense patrol, and accessible to maintenance crews in the confined conditions of a working submarine. The machinery that controlled mine deployment was integrated with the boat's broader systems, creating interdependencies that the fitting-out teams had to map and verify connection by connection. There was no moment in this process where a shortcut could be safely taken. The saddle tanks were not merely structural features, but the operational heart of the vessel's purpose. Inside the hull, the picture was equally complex. The Type X carried a crew substantially larger than a standard attack U-boat, and the designers had to provide for their accommodation, their safety, and their ability to function over patrols that might extend for weeks. Berthing arrangements, galley facilities, storage for provisions, fresh water systems, waste management, none of these were glamorous engineering problems, but all of them had consequences for operational endurance. A crew that could not sleep, could not eat adequately, or could not maintain basic hygiene across a long patrol would degrade in its effectiveness, regardless of how well the mine shafts functioned. The fitting-out teams worked through these systems in sequence, with inspectors from the Naval Engineering Office checking each installation against the specifications before sign-off was granted and the next phase could proceed. Propulsion machinery received particular attention. The Type X was designed to operate over long ocean distances, and its diesel engines had to deliver sufficient power for surface running, while the electric motors and battery banks needed to sustain the boat through extended submerged periods. Installation of these systems in the confined spaces of the lower hull was physically demanding work, requiring specialized technicians who could thread heavy components through hatches and into positions where ordinary industrial logic did not apply. Alignment of propeller shafts had to be achieved with tolerances that would only reveal their adequacy or their failure under the pressures of deep diving and high-speed running. Each engine, each motor, each shaft coupling was a potential point of failure, and the quality of its installation would eventually be tested by conditions no shipyard trial could fully replicate. Once the fitting out was judged complete, the boats moved into the Baltic for sea trials, a phase that every submarine crew and every naval inspector regarded as the true examination of all that had gone before. The Baltic in those years served as Germany's primary submarine proving ground, its relatively sheltered waters offering the space to push new boats through the full range of their designed performance without the additional hazard of open ocean conditions. Trials crews, a mix of experienced submariners and technical specialists, took each Type X through a progressive sequence of tests, beginning with surface handling and gradually moving into the more demanding evaluations of diving, maneuvering at depth, and systems operation under realistic conditions. The results of these trials were instructive in ways that pure calculation had not entirely anticipated. The Type X performed credibly in many respects. Its range was substantial, its mine-laying machinery functioned as designed, and its endurance as a vessel capable of extended ocean operations was confirmed. But the boats were large, and their size imposed costs that became apparent under trial conditions. Submerged maneuvering was sluggish compared to smaller classes, a consequence of displacement that no amount of engineering refinement could entirely overcome. Crash dives, the emergency submergence maneuver that could mean the difference between survival and destruction when an aircraft appeared without warning, took longer than commanders would have preferred. These were not failures of design so much as the honest price of the trade-offs the naval architects had made, but they were noted carefully by the officers who would eventually take these boats to war. The mine-laying systems themselves underwent dedicated testing during trials, with inert practice mines used to verify the sequencing, release mechanisms, and the boat's behavior during the laying process. Each mine had to be deployed consistently at the correct depth on a predictable heading relative to the boat's track. The saddle tank shafts had to purge cleanly, the loading mechanisms had to cycle reliably, and the whole process had to be achievable while the boat was maneuvering at low speed in the dark, with officers navigating by calculation rather than visual reference. Trials revealed minor mechanical adjustments needed in certain shaft mechanisms, modifications that were addressed before the boats were declared operationally ready. These refinements were not embarrassments, they were exactly the kind of discovery that trials existed to produce, and the system worked as intended by catching them before they could compromise an actual mission. The workforce that built the Type X boats worked under conditions that were shaped as much by the political atmosphere of 1930s Germany as by the technical demands of the project. Naval rearmament was a point of national pride in official rhetoric, and workers in the major yards understood themselves to be part of a project with significance well beyond their individual tasks. Overtime was common, quality standards were enforced with unusual rigor, and the culture of the yards during these years reflected a country pouring considerable energy and resource into rebuilding its military instrument after years of constraint. Whether individual workers understood the specific purpose of the vessels taking shape in front of them varied. The external mine shafts were distinctive to any experienced eye, but the broader context of what the Kriegsmarine was building was no secret in the communities that surrounded the major naval yards. By the time the first Type X boats were commissioned into service and their trial certificates signed, Germany was moving toward the war that all this preparation had been designed to prosecute. The boats that slid from their fitting-out berths into the grey waters of the Baltic carried the accumulated labour of years, the drafting tables of the design bureaus, the fabrication floors, the inspection offices, the trials programs, and the hands of thousands of workers who had translated an idea about strategic mine-laying into a physical reality. There was no ceremony that could adequately capture what it meant to finally have these boats ready. The naval officers who received them knew that a vessel's quality is ultimately proved not by its trial certificates, but by what happens when the enemy is present and no one is coming to help. That proof was still ahead of them, waiting in waters that had not yet been plotted on any patrol chart, against an adversary that did not yet know exactly what was coming. The steel hull was finished, the mine shafts were fitted, the machinery was aligned, tested, and certified ready. But a submarine without a crew is nothing more than an expensive steel cylinder, inert, purposeless, and silent for all the wrong reasons. The men who would take the Type X into hostile waters were not chosen at random or assembled in haste. They were selected, evaluated, and shaped by a system that understood, perhaps better than any other branch of the German armed forces, that the quality of a crew was inseparable from the survival of the boat. Selection for U-boat service during the war years was competitive in ways that went beyond physical fitness. The Kriegsmarine looked for a particular kind of man, someone capable of functioning with precision under sustained psychological pressure in an environment designed by nature to kill him. Officers were drawn from the naval academies, men who had already passed through rigorous maritime training and who had demonstrated the temperament to command in confined, high-stakes spaces. Enlisted men came from across the Navy's technical branches: engineers, machinists, electricians, torpedomen, radio men. For the Type X specifically, the requirement was even broader than for the smaller attack boats, because the mine-laying systems demanded additional specialized knowledge that most general U-boat crewmen simply did not possess. The Type X carried a crew considerably larger than the standard Type 7 that formed the backbone of the U-boat arm. Where a Type 7 might sail with fewer than 50 men, the Type X required something closer to 60 or more, a difference that sounds modest on paper but transforms the interior world of a submarine entirely. Every cubic meter of habitable space was already spoken for, and adding more bodies to that equation meant more heat, more noise, more consumption of air and food and water, and more interpersonal friction across the weeks of a long patrol. The Kriegsmarine's planners had accounted for this in the design. The Type X was a larger vessel, but no amount of planning fully prepared a crew for the reality of living in that compressed world. Training began in the Baltic, far from the Atlantic War and its consequences. The Baltic in the early war years was a protected space in operational terms, a German lake, to use the phrase common, among naval planners, and it served as the classroom in which U-boat crews were formed. For a Type X crew, the training syllabus extended well beyond the standard workup given to crews of attack submarines. Mine-laying procedures were drilled with exhausting repetition. The mechanics of flooding and clearing the external mine shafts, the precise sequencing of releases, the navigation protocols that ensured mines were laid along planned lines rather than scattered randomly. A mine laid incorrectly was not merely wasted, it was a hazard to the boat that had laid it, and the men who operated the mine systems understood this with cold clarity. The relationship between officers and enlisted men aboard a U-boat occupied a social world unlike anything in the surface navy. Rank still mattered. It mattered absolutely when it came to decisions and commands, but the physical reality of submarine life stripped away most of the ceremonial distance that rank maintained on larger vessels. A commander aboard a Type X could not retreat to private quarters that were genuinely private. A petty officer could not avoid proximity to his senior men for months at a time. Everyone ate from the same galley, breathed the same recycled air, and heard the same sounds in the dark. This enforced closeness created bonds of a particular intensity, and it also created the conditions in which personal tensions, if left unmanaged, could corrode a crew's effectiveness, as surely as salt water corroded steel. Daily life aboard the Type X during a patrol settled into a rhythm that was at once deeply monotonous and laced with the constant low-frequency awareness of danger. The watch system divided the day into rotations: men on duty at their stations, men resting in their bunks, men eating in the brief windows the galley schedule permitted. Sleep was a transaction rather than a luxury grabbed, when available, interrupted by dive alarms and machinery noise and the simple fact that several men shared each pair of bunks in a hot bunking arrangement that gave a sailor little sense of personal territory. The food was the famous point of morale management in all U-boat narratives. The early days of a patrol brought fresh bread and meat, but within a week those were gone, and the crew subsisted on preserved and canned provisions that blurred one meal into the next. What distinguished the Type X crew's experience from that of men aboard attack submarines was, at its core, a question of purpose and consequence. The men on a Type 7 or Type 9 who fired a torpedo at a convoy could hear the detonation, could mark the result in the log, could return to port with a confirmed sinking to their name. The kill was real, witnessed, and verifiable. The men of the Type X operated under a fundamentally different relationship to the violence they inflicted. They would approach a coastline or a shipping lane in darkness, run the mine-laying sequence with careful precision, and then turn away, leaving behind a field of weapons that might lie on the seabed for days, weeks, or months before claiming a victim, if they claimed one at all. There was no explosion to hear, no column of smoke to observe, no immediate proof that the hours of risk had produced any result. This invisible quality of mine warfare was not merely a technical curiosity, it had a measurable effect on the psychology of the men who conducted it. Sailors across all navies and all wars tend to build their sense of professional worth around outcomes they can see and measure. A torpedo crew could speak of kills. A mine-laying crew could speak only of missions completed. The confirmation of what those mines had done, if it came at all, arrived through intelligence briefings weeks later, filtered through layers of abstraction that made it difficult to connect to the men who had actually placed the weapons. Veterans of mine-laying submarines in later years would describe this as a particular kind of psychological weight, not the guilt of killing, which is itself a different burden, but the uncertainty of not knowing whether you had killed at all and whether the risk had meant anything. The officers who commanded Type X boats were, by the standards of the U-boat arm, senior men experienced, steady, and capable of managing both the technical complexity of mine-laying operations and the human complexity of a larger crew on extended patrols. The commander occupied a position of near absolute authority that was simultaneously that of naval officer, father figure, and arbitrator of morale. How he handled a crew's anxiety during a prolonged depth charging, how he maintained discipline when food ran low and tempers shortened, how he communicated confidence or concealed the lack of it, shaped the character of every patrol. The best Type X commanders were men who understood that running a large mine-laying submarine demanded different qualities than the aggressive hunter's instinct celebrated in the stories of U-boat aces. Patience, precision, and discretion were the virtues that the mission rewarded. There was also the specific burden of operating a vessel whose primary weapon was not carried inside the hull but hung in the external saddle tanks, exposed to depth charge pressure, to mechanical wear, and to the thousand small variables of extended ocean voyaging. The men responsible for the mine-laying systems lived with the knowledge that they were escorting a cargo of armed, sensitive devices through some of the most turbulent and heavily patrolled waters on Earth. Damage to a mine shaft from a near-miss depth charge was not simply a technical problem, it was a problem that could make the boat itself dangerous, with armed mines potentially compromised in their housings. The mine specialists aboard the Type X carried a quiet, professional anxiety that was entirely their own. The Baltic training phase could last many months before a crew was judged ready for operational deployment. Commanders worked their boats through simulated mine-laying runs, navigation exercises in restricted waters, emergency dive drills, and the exhaustive fault-finding that revealed which crew members would hold and which would fracture under sustained stress. By the time a Type X crew left for their first operational patrol, they were not merely trained, they were a formed unit. A group of men whose individual capabilities had been tested against one another and against the machine until the boat and its complement functioned as a single integrated system. The training was the foundation, and everything that followed, every dark approach to an enemy coastline, every silent run through a mine channel, every long submerged day waiting for the night was built on it. When those men finally took the Type X into the operational sea lanes, they carried with them all of that accumulated preparation, all of that compressed professional knowledge, and alongside it something harder to name, the particular composure of men who had made peace with the terms of their service. They would go out into waters where the enemy was actively hunting them. They would lay weapons they might never see detonate. They would return to port with mission logs and fuel consumption figures and mine tallies, and they would wait sometimes for a long time to learn whether any of it had mattered. That waiting, that distance from consequence, was the defining condition of their war. They did not pull triggers and watch things fall. They left a signature on the seafloor and turned away into the dark. When a Type X boat slipped its moorings and moved out into open water for the first time on a combat patrol, it carried with it the weight of years of design work, months of crew training, and a weapon that would not announce itself for days or weeks after the boat had already turned for home. There was no artillery exchange to mark the mission's beginning, no visible enemy to fix in the sights of a periscope. The men aboard knew they were going to war, but the war they were going to was one of patience, geometry, and concealment. Every patrol began in the same fundamental silence, engines turning, the shoreline receding, the boat settling into the rhythms of the sea. The officers on the bridge scanned the horizon not with the appetite of men hunting a target they could see, but with the vigilance of men who understood that their deadliest enemy might arrive from above, not ahead. That awareness of the aircraft, the escort vessel, the listening hydrophone would stay with the crew for the entirety of the patrol, from the moment the harbour lights disappeared behind them to the moment they made landfall again. The routes these boats followed were not improvised. They were the product of careful planning by staff officers who studied convoy charts, current reports, and intelligence assessments with the same intensity that a surgeon studies an anatomy diagram before an operation. From the ports of northern Germany and, as the war progressed, from the Norwegian fjord bases that extended Germany's reach dramatically westward, the Type X boats moved along corridors designed to minimize exposure while maximizing the ground they could cover before they reached their assigned laying fields. The North Sea was shallow and dangerously well patrolled in its southern reaches, forcing navigators to account for water depth not just as a tactical consideration, but as an engineering constraint. A Type X boat needed sufficient depth beneath its keel to maneuver safely, and in the shoal waters near enemy coastlines that margin could grow uncomfortably thin. The approaches to British ports were among the most closely watched stretches of water in the world by this point in the war, ringed by patrol aircraft, destroyer flotillas, and an ever-thickening web of hydrophone stations that could pick up the sound of turning screws at considerable distance. To reach these waters without being detected was, in itself, a significant operational achievement before a single mine had been laid. Submerged transit was the dominant mode of travel for much of any patrol in these contested waters, and this placed immediate demands on both the boat and its crew. Running submerged at patrol depth conserved the boat's invisibility but drained the batteries that powered the electric motors, and the Type X's considerable size meant those motors were working against a larger mass. The boat's engineers maintained careful watch over battery levels, balancing the need to stay down against the need to surface periodically under cover of darkness to run the diesel engines and recharge. These surfacing windows were planned with almost liturgical precision, timed for the hours least likely to coincide with Allied air patrols, chosen on nights when cloud cover offered some shelter from the searching beams of patrol aircraft. The crew of a Type X boat understood that each surfacing was a calculated exposure, a few hours of vulnerability accepted in exchange for the power reserves that would keep them alive and moving the following day. When the diesels cut out and the vents opened and the boat slipped below the surface again at the approach of dawn, there was something close to relief in the control room, a collective easing of held breath. Navigation in the open Atlantic carried its own demands, but it was the approach to the laying field itself that concentrated every faculty a crew possessed. The mine-laying grounds were chosen specifically because they were dangerous to reach waters close to harbour approaches, inside or adjacent to swept channels, along the routes that Allied convoys and coastal traffic used, with enough regularity to make mining them strategically worthwhile. Reaching these areas undetected required the navigator to work with charts that were never fully current, in water that might have been swept since those charts were drawn, through patrol patterns that changed with Allied operational needs. A navigational error here was not merely inconvenient, it could mean laying mines in positions that would never threaten enemy shipping, or worse, grounding the boat in shallow water far from any hope of assistance. The navigator's work in those final hours before the laying began was among the most concentrated and consequential effort performed aboard any vessel in the German fleet. The actual process of laying mines was a mechanical operation as much as a tactical one, and it demanded sustained technical discipline from the engineering spaces below. The Type X's mine shafts, built into the external saddle tanks that flanked the pressure hull, allowed mines to be deployed without exposing them to the interior atmosphere of the boat, a significant safety advantage. But the mechanism that released them was not forgiving of mishandling. At the navigator's instruction, the boat would settle into the laying run, a straight, controlled course held at a precise depth and speed, while the mines were dropped at calculated intervals behind the boat's track. The spacing between mines mattered enormously. Too close together and the field wasted its capacity in a small area. Too far apart and the gaps became wide enough for a careful minesweeper to exploit. The men who managed the mine release equipment worked in the kind of focused quiet that only comes when the consequences of error are immediate and total. There was no second pass, no correcting a mine already deployed. Each one fell away into the darkness of the water below and was gone. The laying runs were almost always conducted at night and at low speed, which placed the boat in an extended period of reduced maneuverability, while in waters where Allied patrols were a constant possibility. Hydrophone operators listened with absolute concentration throughout, reporting any contact to the commander immediately. A destroyer contact during a laying run presented one of the most difficult command decisions in submarine warfare. Breaking off the run meant an incomplete field and a failed mission, while continuing meant accepting increased risk to the boat and every man aboard. Commanders developed their own instincts about when to press on and when to abort, judgments shaped by experience, training, and the particular acoustic signature of whatever contact the hydrophones were reporting. The standing orders gave commanders latitude, but the responsibility was entirely personal, and the men who exercised it well understood both the value of what they were deploying and the irreplaceability of the boat and crew doing the deploying. The mechanical demands did not ease once the last mine had been released. Clearing the laying area required the same careful navigation in reverse. The boat needed to exit the field it had just created without triggering one of its own weapons. A danger that was real and not merely theoretical, given that the influence mines the Type X often carried could respond to the magnetic signature of any sufficiently large steel hull, including the one that had just laid them. The mine settings could be programmed with time delays before activation, giving the laying boat a window in which it could move clear without risk. But those windows were finite, and the exits from shallow coastal waters were not always straightforward. Once clear, the boat resumed its normal patrol posture and began the long transit back toward base, carrying with it no confirmation of what the mines might eventually achieve. That absence of immediate feedback was one of the stranger psychological features of mine-laying service, and it shaped the texture of life aboard a Type X boat in ways that distinguished it from the experience of a conventional attack submarine. A torpedo boat crew knew within minutes whether their weapon had found its mark, the explosion, the secondary detonations, the sound of a ship going down, carried through the water with terrible clarity. A mine-laying crew had none of that. They returned to port, having completed their mission with professional thoroughness, and then waited, sometimes for weeks, to learn whether any of their weapons had actually functioned. The intelligence that eventually filtered back shipping losses in a particular area, reports of convoy disruptions, Allied mine clearance operations detected in the right locations, was indirect and often ambiguous. There was satisfaction in it when it came, but it was a quiet satisfaction, removed from the act of laying by enough time and uncertainty that it never felt entirely connected. The return passage carried its own dangers, and crews were under no instruction to relax their vigilance simply because their operational objective had been achieved. The Allied ASW net that had to be threaded on the way in had to be threaded again on the way out, and in the early war years, the boat had typically been at sea long enough that new patrol patterns might have been established in the intervening time. There were also the practical demands of a large submarine operating at the limits of its endurance, food stores running low, minor mechanical defects accumulating in systems that had been running continuously for weeks, crew fatigue settling into the bones of men who had been sleeping in rotation in cramped bunks while the boat moved through cold and hostile water. The final days of any patrol were a test of institutional discipline, the professionalism of officers and petty officers holding the crew together through sheer force of trained habit, when individual motivation might otherwise have begun to fray. When a Type X boat finally made port, the reception was quieter than the return of a boat that had sunk ships. There were no tonnage tallies to announce, no dramatic accounting of what the crew had accomplished against the enemy. The mines were gone, the patrol was complete, and whatever they had achieved would remain invisible for days or weeks to come. The officers filed their patrol reports with clinical precision, laying positions, mine counts, navigation observations, any contacts encountered, and the staff analysts who received those reports would begin the patient work of correlating them against future intelligence. The crew stood down to rest and maintenance, existing for a time in a peculiar limbo between the completion of a mission and the knowledge of its results. It was the condition of mine-laying service distilled to its purest form, the act of war carried out in silence, the outcome surrendered to the sea, the record of success or failure written not by the crew itself but by the ships that would cross those waters in the weeks ahead. The early patrols established the operational rhythm that would define the Type X's wartime existence, the careful route planning, the submerged transits, the precision of the laying run, the long return in a state of sustained watchfulness. Each patrol was an exercise in professional restraint, the suppression of the more visible and immediate satisfactions of naval combat in favor of a patient, calculated form of destruction that worked by proxy and at a distance. The men who performed this work understood its value in the abstract, understood that a minefield in the right position could achieve more disruption than a dozen torpedo attacks against individual targets. But understanding the strategic logic of what you do is a different thing from feeling it, and the men who crewed those early patrols carried their missions home in the particular quietness of men who had done something important that the world would not immediately see. The boat slips back into port. The crew comes ashore. The mission, by every visible measure, is complete. There are no burning hulks on the horizon, no columns of smoke rising from stricken ships. The officers file their patrol reports. The engineers begin their post-voyage checks, and the men who have spent weeks in the cold and pressure of the deep find their way to dry land, to warm food, to sleep. And somewhere far behind them, in waters that look the same as they always have, the minds settle into the darkness and wait. That waiting is everything. The mine-laying submarine's most unusual quality is the gap between action and consequence. A torpedo crew knows within seconds whether they have succeeded. The mine-laying crew knows nothing, not for days, sometimes not for weeks, sometimes not at all. The ocean keeps its own records. Allied vessels moving through waters the German planners had carefully seeded had no reason to expect danger. There were no warnings written into the water. Shipping lanes that had been transited safely 100 times before were now transited 101 times, and on that 102nd passage, the seafloor would answer. That asymmetry, the complete absence of drama at the moment of laying, the sudden catastrophic drama at the moment of detonation was not a flaw in the weapon, it was the entire point. When an Allied vessel struck a mine, the first question asked by every naval authority responsible for that stretch of water was almost always the same. How did mines get here? Established convoy routes had been swept. Patrol vessels had worked these channels. Harbour approaches were monitored. And yet the mines were there, and that fact required an explanation that cut to the heart of Allied confidence in their own intelligence and their own control of the sea surface. The mine-laying submarine solved that problem for Germany beautifully and brutally. Because the Type X boats operated at depth, at night, in conditions that made surface observation unreliable, and because their external mine shafts allowed deployment without surfacing at all, there was no moment of exposure that Allied patrols could reliably intercept. The mines appeared because nothing had been seen, and nothing being seen was the entire achievement. The immediate operational consequences of a successful mining were not always a sinking. They were, in many ways, something more strategically durable. A single sinking in a busy shipping lane does not close that lane, it complicates it. It forces the commodore of the next convoy to reconsider the routing. It forces the harbour master to order a mine-sweeping sweep before the next scheduled arrival. It forces the local naval command to widen its patrol area, to redirect resources, to delay sailings that had been planned days or weeks in advance. Multiply that disruption across several successful Type X patrols in the same general region, and the effect compounds. Convoys are rerouted by tens of kilometers, adding time and fuel costs. Arrivals are delayed by hours or days. Ports that were running on tight logistical schedules begin to accumulate backlogs. The entire system of supply, already under strain from German surface raiders, aircraft, and conventional U-boats, finds another point of friction inserted precisely where planners had believed the route was clear. Allied mine-sweeping operations in response to the mine-laying threat were, by any measure, a vast undertaking. Sweeping a sea lane was not a casual procedure. It required dedicated vessels, slow, unglamorous, extraordinarily dangerous ships, crewed by men who understood that the waters they worked were by definition already proven lethal. The sweepers worked in patterns, dragging cutting gear and influence sweep equipment through lanes that needed to be certified safe before convoys could proceed. In stretches of water where the Germans had used magnetic mines rather than conventional contact mines, the sweeper crews had to contend with a weapon that did not need to be physically struck to detonate, but would fire in response to the magnetic signature of a steel-hulled vessel passing overhead. This forced the development and deployment of degaussing, a technology that reduced a ship's magnetic signature, and the use of wooden-hulled or non-magnetic sweepers in areas where magnetic mines were suspected. Every one of those adaptations cost time, material, and expertise that the Allies could not afford to waste. Harbour operations felt the pressure acutely. The approaches to major British and Allied ports were among the areas most vulnerable to covert mining, because their importance made them predictable targets. A mine layer did not need to know the exact departure time of a convoy. It needed only to know that a particular channel was used continuously, and that any mine placed there would eventually find a hull. Port authorities along the Atlantic and North Sea coastlines developed increasingly elaborate routines for sweeping approach channels, and those routines themselves became a source of delay. A harbour that had once accepted ships around the clock found itself operating within swept channel windows time periods after a fresh sweep during which arrivals were considered relatively safe. Ships waiting outside those windows burned fuel at anchor, crews sat idle, cargo that needed to move did not move. The mine had been laid weeks earlier and hundreds of kilometres away, and it was still, through this chain of forced responses, consuming Allied resources daily. The psychological dimension of mining on Allied merchant seamen should not be separated from the tactical picture. The torpedo attack, for all its lethality, presented itself. A wake in the water, the silhouette of a periscope, the last-second recognition of danger, there was at least the possibility of seeing it coming. The mine offered nothing. A ship that was steaming normally through a cleared channel, with no tactical alert raised, no contact report from the escort, that ship could simply cease to exist without warning. For crews who had already survived torpedo attacks, depth charge near misses, and air raids, the idea of striking an invisible object in waters certified as swept carried a particular and irrational terror. It was not the fear of combat, it was the fear of the floor giving way. Merchant seamen were not cowards. The casualty rates among Allied merchant fleets stand as one of the quiet, extraordinary facts of the war at sea. But human endurance has its texture, and the mine's refusal to announce itself wore at that texture in ways that a visible enemy could not. The Germans were not unaware of this dimension. The deployment of mines in psychological proximity to major Allied ports, in channels used by troop ships as well as cargo vessels, was not accidental. There was a targeting logic that went beyond the simple arithmetic of ships sunk. If a major port could be made to feel unsafe, if the approach to a harbour that handled thousands of tons of material per day could be rendered uncertain, then the mine was functioning not just as a kinetic weapon, but as a weapon of institutional anxiety. Rerouting decisions made at the Commodore level, sweep schedules ordered by port admirals, intelligence assessments generated by naval staffs, trying to understand where the mines were coming from. All of these consumed planning effort that would otherwise have been directed at offensive operations. Germany's mine-laying campaign, and the Type X's particular contribution to it, was in this sense a force multiplier. A handful of submarines, deploying mines they would never see detonate, were generating operational consequences far out of proportion to their raw numbers. Allied intelligence worked to understand the geometry of the threat. Mine strikes in a particular stretch of water could be mapped, and the map sometimes suggested the laying pattern, which in turn could suggest the approach route, which might, under the right conditions, help narrow down which U-boat had been responsible. This was painstaking work, more archaeology than detection, and it rarely produced results fast enough to intercept the boat responsible. By the time analysts had assembled a picture of where a minefield had been laid and from what direction, the Type X responsible had long since returned to port, refitted, and potentially departed again. The intelligence lag was enormous. What the analysis could do was inform future sweep priorities, confirm suspected mining areas before shipping was routed through them, and occasionally generate useful data for the broader effort to understand German U-boat patrol patterns. It was not nothing, but it was slow, and the mines did not wait for conclusions. The resource cost to the Allies extended far beyond the minesweepers themselves. Every mine strike that damaged rather than sank a vessel created a repair burden on Allied dockyards already working at maximum capacity. Ships pulled from service for hull repairs were ships not carrying cargo. Escort vessels temporarily damaged by mines or mine-like detonations were vessels not protecting convoys. The ripple effect of a successful mining operation through the entire Allied logistics chain was genuinely difficult to quantify with precision, but it was real, and it was cumulative. The Admiralty's planners understood this. The effort directed at countering the mine threat in swept channels, in harbour defence, in the degaussing of hulls, in the construction and crewing of dedicated minesweepers represented a permanent tax on Allied naval capacity that the German mine-laying campaign had imposed, and that only the collapse of that campaign's source could. Remove. For the men aboard the Type X boats, the results of their work remained largely abstract. They returned to port, submitted their patrol logs, noting times, coordinates, and mine deployments, and waited for the intelligence summaries that occasionally confirmed a ship had gone down in waters they had seeded. Sometimes, confirmation came. More often, it did not, or came weeks later and indirectly, through a monitoring of Allied shipping reports or the radio traffic of enemy naval commands. There was no cheering at a kill. There was, at most, a quiet entry in a record. The weapon was invisible, the result was distant, and the man who had laid the mine was by then already preparing for the next patrol. That distance between act and consequence, between sailor and victim, was not incidental to the nature of mine warfare. It was its defining character, and it shaped everything about how the Type X and its crews fit into the broader fabric of the war beneath the waves. The mines had done their work in silence. Ships had gone down in waters charted as safe, convoys had been rerouted around invisible dangers, and harbours had been closed while frantic sweeping operations cleared lanes that should never have needed clearing. But silence, in war, is never permanent. Sooner or later, the men hunting the hunters find a thread to pull. For the Allies, the question of who was laying mines in those protected waters and how to stop them became one of the most pressing intelligence problems of the early naval war. The answer, when it began to emerge, pointed not to surface minelayers or aircraft, but to large submarines moving through the darkness, far from where anyone expected them to be. The first challenge was identification. When a ship struck a mine, it rarely left behind clean evidence of where the weapon came from or how it arrived. Minesweeping crews recovered fragments, occasionally intact mechanisms, and naval ordnance analysts worked methodically to catalogue what they found. The mines themselves carried fingerprints, manufacturing tolerances, triggering mechanisms. The specific geometry of mooring arrangements and British naval intelligence developed the painstaking discipline of reading those fingerprints back toward their source. Over time, patterns emerged. Certain mine types appeared in waters that surface vessels could not have reached without being observed. The inference was uncomfortable but unavoidable. Something large was passing through the outer approaches, submerged, seeding destruction, and departing before dawn. Aerial reconnaissance became the first active tool in the Allied response. Coastal Command aircraft began flying extended patrols over the likeliest mining corridors, the deep-water approaches to British ports, the lanes used by inbound Atlantic convoys, and the northern passages where traffic funneled between Scotland and Norway. Crews were briefed not only to watch for surface submarines, but to photograph the sea surface itself, looking for the slight discoloration, the faint oil trace, or the barely perceptible disturbance that might indicate a submerged vessel had recently passed. It was imprecise work, dependent on weather, light, and the unforgiving geometry of searching an ocean from above. Results were modest at first. The Type X boats were deep and careful, and the men commanding them understood that dawn was not their friend. What gave the Allied effort genuine traction was intelligence work of a different order entirely. The signals analysts working at Bletchley Park and in the Naval Intelligence Directorates were engaged in the long, grinding effort to read German naval communications. Operational orders, patrol assignments, port departure signals, and the routine traffic of a naval bureaucracy that could not function without radio, all of it fed into an analytic process that, when it worked, could tell Allied planners not merely where a U-boat had been, but where it was likely to go next. The Type X boats were large enough and their patrols long enough that their movements generated substantial radio traffic. Each transit, each rendezvous, each request for updated target coordinates left faint traces in the ether, and the patient accumulation of those traces began to build a picture. That picture was never complete. German naval cipher security was sophisticated, and the intelligence advantage the Allies were developing was fragile, intermittent, and fiercely protected to prevent the Germans from realizing it existed. Operational commanders could not always act directly on what signals intelligence revealed, doing so too obviously would betray the source. Instead, the intelligence was used to shape patrol assignments, to position escort forces, to route convoys slightly away from areas where a Type X boat was suspected to be working. The Type X crews, puzzled that their carefully chosen positions sometimes seemed to have been anticipated, had no way of knowing how thoroughly they were being read. They attributed the occasional near miss to bad luck, to improved Allied patrolling, to the ordinary hazards of a war that was becoming denser and more dangerous by the month. Surface escort groups adapted their tactics as understanding of the mine-laying threat deepened. The standard anti-submarine response to a contact-aggressive prosecution depth charges in a disciplined pattern, hold until the target surfaced or debris confirmed, a kill remained the core of what escort commanders tried to do. But against a large submarine operating at depth in open water, the acoustic conditions were rarely ideal. ASDIC, the British underwater detection system, had real limitations against a deep, slow-moving contact in the kind of thermal layering that the North Atlantic produced in abundance. The Type X boats were not fast, but they were large enough to absorb punishment that would have broken smaller submarines, and their commanders had been trained to go deep and go quiet when threatened. Prosecuting a contact to a confirmed kill against such a boat required patience, fuel, time, and numbers that escort groups did not always have. The development of airborne radar changed the calculus considerably, as Allied aircraft began carrying centimetric radar sets capable of detecting a surface submarine at ranges measured in miles rather than yards. The freedom of movement that U-boat commanders had previously enjoyed on the surface began to erode. The Type X boats, larger than any standard combat U-boat, presented a correspondingly larger radar return. A boat running on the surface to charge batteries or to conduct a mine-laying approach could now be detected before its lookouts heard an engine or saw a silhouette against the sky. The response time available to a crew that received a radar contact warning was measured in seconds, and at operational depth a Type X boat could not always clear the surface fast enough. The sea above began to feel like a ceiling as much as an escape route. Signals intelligence and aerial patrol reinforced each other in a feedback loop that Allied planners worked deliberately to tighten. When decrypted traffic or traffic analysis suggested a Type X boat was operating in a particular region, Coastal Command could saturate that region with aircraft sorties for a period of days. Even if no contact was made, the effect was to compress the area in which the boat could safely surface, forcing the crew to extend their time at depth, to delay mine-laying approaches, to consume battery capacity at rates that reduced their operational range. The psychological pressure on crews who knew they were being hunted without being able to see their hunters was significant. Reports from returning patrols spoke of sustained periods at depth, of the slow accumulation of carbon dioxide, of the way time expanded when every sound above was potentially a warship. Harbour intelligence contributed another layer to the Allied picture. Neutral countries whose ports and waters German submarines occasionally transited had their own watchers and informants, and information flowed not always quickly, not always reliably toward Allied naval intelligence through diplomatic and human channels. Norwegian resistance networks, after Germany's occupation of Norway, developed into a particularly valuable source of observation. Shore-based watchers tracked submarine movements through the fjords, recorded the arrival and departure of large boats from identified bases, and passed that information by clandestine means to London. A Type X boat preparing for a patrol, loading mines at a Norwegian facility, was not invisible to every set of eyes in the vicinity, however carefully its commanders managed their operational security. The Allied effort to counter the Type X was never a single operation with a defined objective. It was a sustained, evolving pressure applied through a dozen different means simultaneously: intelligence, patrol, detection, routing, and the grinding work of minesweeping that denied the enemy the full measure of what their mines might otherwise have achieved. The Type X boats were never swept from the sea in a single dramatic campaign. They were worn down, constrained, occasionally caught, and progressively denied the freedom of action they had needed to be effective. Each patrol that was forced to abort, each mine-laying approach that had to be abandoned because the acoustic environment above the hull spoke of active warships, represented a kind of invisible Allied victory, one that never appeared in the communiques, but that mattered nonetheless. By the middle years of the war, the operational environment facing the Type X boats had transformed almost beyond recognition from what it had been when the first patrols set out. The approaches to British ports that had once offered relative freedom now bristled with patrols, radar sweeps, and the kind of integrated air and sea coordination that the Allies had taken years of painful experience to develop. The time window during which a mine-laying approach could be completed under acceptable risk had narrowed. The waters that had once absorbed a large submarine's passage without comment now seemed to notice every disturbance. The men aboard the Type X boats were not less skilled than the men who had conducted those first patrols. The world in which they were trying to work had simply become far more lethal, far more alert, and far less forgiving of the margin of error that mine-laying at depth and in confined approaches inevitably required. What this chapter of the war reveals, in the end, is how two sides in a naval contest learned from each other without ever sitting across a table. Every Allied loss to a mine-generated analysis that refined the response. Every refinement in the Allied response forced a change in how the Type X operated. Every operational change left new traces in the signals traffic, in the mine recovery data, in the accounts of crews who came home and submitted their patrol logs to men who read them with exhausted, meticulous attention. It was a conversation conducted in depth charges and cryptanalysis, in radar returns and oxygen levels, in the slow brightening of Allied intelligence against the darkness that the Type X boats had for a time made their home. The boats had built their reputation on being unseen. The Allies had spent 4 years learning, at enormous cost, exactly how to see them. Before the occupation of Norway, every Type X boat leaving a German port carried a silent burden: distance. The North Sea was a gauntlet. British patrols stretched across the gap between Scotland and Norway like a drawn curtain, and every nautical mile a submarine burned reaching open. Atlantic water was a mile subtracted from its operational range, its mine capacity, its margin for survival. The Kriegsmarine had understood this geography as a constraint for years, an uncomfortable arithmetic written into every patrol plan. Then, in the spring of 1940, that arithmetic changed. Germany's seizure of Norway was not merely a land campaign or a blow against a neutral nation. It was a strategic rewriting of the map, and nowhere in the U-boat arm was that rewriting felt more immediately than among the planners responsible for the mine-laying fleet. The fjords of western Norway were, by any measure, extraordinary gifts to a submarine navy. Carved by glaciers over millennia, they offered deep, sheltered water running far inland, screened on 3 sides by rock, hidden from air observation by the overhang of cliff faces, and positioned hundreds of nautical miles closer to the open Atlantic than anything Germany could offer from its home ports. For the Type X, already a large vessel demanding careful logistical support, these bases represented something close to a transformation. A boat departing from a Norwegian fjord port could bypass the most dangerous corridor of the North Sea transit almost entirely. The fuel saved, the hours not spent running submerged through mined channels and patrol zones, translated directly into operational reach. Waters that had once sat at the extreme edge of a Type X patrol envelope were suddenly accessible with meaningful mine loads still aboard. Bergen, Trondheim, and later Narvik became the anchors of this new strategic geography. Each offered different advantages. Bergen sat closest to the British Isles, making it ideal for patrols aimed at the western approaches and the coastal shipping lanes that fed the arteries of British industry. Trondheim, further north, pointed toward the Arctic, toward the convoy routes that would eventually run supplies to the Soviet Union after 1941. These were not improvised arrangements. German naval engineers moved quickly to convert existing harbour facilities, construct sheltered pens where possible, and establish fuel and torpedo depots that could sustain extended U-boat operations. The infrastructure that emerged over months was modest compared to the great concrete bunkers eventually built at Lorient or Saint-Nazaire, but it was functional, and for the Type X it was enough. The logistics of operating from Norwegian bases required adjustments the crews and their commanders had not fully anticipated. The fjords themselves presented navigation challenges of a particular kind. a submarine moving through narrow, deep-sided channels in darkness, with tidal currents running unpredictably and charts that were sometimes less detailed than the terrain demanded, was operating at the edge of what was safe even before it reached open water. For a vessel the size of a Type X, the margins were tighter still. Officers who had trained in the wide, forgiving waters of the Baltic found themselves conning a large submarine through passages where errors of judgment carried consequences that could not be corrected. The pilots who guided vessels through the most difficult sections of these entries and exits were invaluable, and their local knowledge became a form of operational currency. What the Norwegian bases enabled, more than anything else, was reach into the Arctic. When Germany invaded the Soviet Union in the summer of 1941, the Allied response included the opening of the Arctic convoy route, a supply line running from British and later American ports, north around the Norwegian Cape, and east to the Soviet ports of Murmansk and Archangel. This route became one of the most strategically significant and physically brutal shipping lanes of the entire war. The seas were violent, the weather frequently lethal, and German forces' surface ships, aircraft, and submarines contested every convoy with unrelenting attention. The Type X boats, repositioned to exploit Norwegian basing, were now within practical reach of the approaches to this route. Their mines could be laid in waters through which those convoys were funneled, in the deep water channels south of the Arctic ice line, in the approaches to Soviet harbours that Allied ships had to navigate with no choice of alternative. The operational picture was not, however, as clean as the geography suggested. The Arctic environment imposed costs that even the most carefully planned logistics could not fully absorb. Cold of a severity that affected mechanical systems, sea states that made precise mine-laying far more difficult than the calm water calculations of a design bureau had assumed, and the particular challenge of navigating in waters where magnetic compasses behaved erratically near the polar regions. These were realities that greeted every Type X crew venturing north. Mines had to be laid with precision to create effective fields, and precision demanded stability and accurate position fixing. In Arctic conditions, both were luxuries. Crews learned to adapt, to accept rougher positioning tolerances, and to trust that the cumulative effect of their fields would achieve disruption even when individual placements were not exact. The Allied response to the new strategic threat posed by Norwegian-based submarines was swift, if not always immediately effective. Royal Air Force Coastal Command extended its patrol coverage over the Norwegian coast, and the Fleet Air Arm mounted strikes against harbour facilities and anchored vessels. The problem was one of range and risk. Norwegian targets lay at the outer edge of what British aircraft could reach, and the German air defences established over the occupied coast were formidable. Strike operations against Bergen and Trondheim were carried out at real cost, and while they damaged facilities and occasionally caught submarines in exposed positions, they could not interdict the flow of U-boat operations with any consistency. The fjords were simply too deep, the terrain too protective, and the target windows too brief. Intelligence work complemented the air campaign. Allied analysts worked to understand the patterns of Type X departure and return, to infer from decrypted signals and aerial reconnaissance when and where mine-laying patrols might be expected. This was painstaking work, partly because the Type X operated far less frequently than the standard U-boat types. Its patrols were longer, its returns less predictable, and its operational signatures harder to read within the noise of a much larger submarine campaign. When intelligence did produce actionable leads, destroyer patrols and submarine patrols of the Royal Navy's own were directed to intercept or at least complicate the passages in and out of Norwegian waters. The record of these efforts was mixed. Some patrols were disrupted, others ran their full course entirely uncontested. The mine-sweeping burden generated by Type X operations in northern waters fell disproportionately on already stretched Allied resources. Every field that had to be swept before a convoy corridor was judged safe consumed days of effort, specialist vessels, and the particular courage of crews who probed water, known to be dangerous, with equipment that was never fully adequate to the task. The disruption was cumulative in ways that never appeared on any single day's operational report, but accumulated over months into route diversions, delayed departures, and the grinding of a machinery that was trying to move supply across a contested ocean. From the perspective of the Kriegsmarine, this was exactly the intended effect. The Type X did not need to witness a sinking to have achieved its purpose. The mine, once laid, worked on its own schedule, and the anxiety it seeded in Allied planning staffs was itself a form of strategic return. The Norwegian bases also changed the social and psychological texture of service aboard the Type X boats in ways that were subtle but real. The fjord ports had a particular quality: isolated, cold, hemmed in by rock and winter darkness for much of the year, yet possessed of a strange, austere beauty that men who served there did not easily forget. The towns that hosted German naval personnel were occupied places, their populations resentful in ways that ranged from quiet withdrawal to acts of open courage in passing information to Allied agents. The German sailors who spent their between-patrol weeks in these ports existed in an odd suspension, neither at the front in any conventional sense, nor at home. They were guests of a conquest, lodged in a landscape that did not want them, waiting to return to a sea that might kill them. As Allied air power over the North Atlantic and Norwegian Sea grew progressively stronger through 1942 and into 1943, the calculus of operating from Norwegian bases began to shift. The same geography that had offered shelter now concentrated risk. Aircraft hunting submarines in the Norwegian Sea had fewer routing alternatives to cover than in the open Atlantic, and the fjord approaches, well known to Allied planners, became predictable zones of danger. The Type X, large and slow to dive, was more vulnerable to airborne attack than smaller classes, and the expanding reach of Allied aircraft began to press against the windows of safety that the Norwegian bases had once seemed to guarantee. What had felt like a strategic opening was gradually narrowing, and the commanders responsible for planning Type X patrols felt that narrowing in the weight of each departure order they signed. Norway had offered the Type X something no amount of engineering could provide: proximity. It had compressed the strategic distance between Germany and its targets, placed the mine-laying boats within reach of waters that mattered critically to the Allied war effort, and given them a protected foothold in a geography they could never have claimed from home ports alone. The toll this took on the Allied effort to keep Arctic convoys moving was real, measured not in dramatic single engagements, but in the slow accumulation of disrupted routes, swept fields, and diverted tonnage. Yet the window in which those advantages could be fully exploited was shorter than the Kriegsmarine had hoped. The war was moving at a pace the occupation of Norway had bought time against but could not ultimately arrest, and the Northern Theatre, like every other, would eventually close in around the boats that had briefly made it their own. There is a particular kind of desperation that does not announce itself loudly. It arrives quietly, dressed in the language of pragmatism and operational flexibility. It shows up in staff meetings as a sensible reallocation of resources. It is written into operational orders with calm, bureaucratic precision. But underneath the composed language, something is shifting. A war machine beginning to improvise, reaching for tools that were built for one purpose and pressing them into the service of another. For the Type X, that moment came somewhere in the middle years of the war, and it told a story that no amount of official language could entirely conceal. By the time the tide in the Atlantic began to turn against Germany, the Kriegsmarine was already managing scarcity. Surface warships that might once have supported extended operations in distant waters were increasingly pinned down, damaged, or sunk. The supply network that had sustained German naval activity across vast stretches of ocean was under sustained, mounting pressure. The great surface supply vessels, the milch cows of the surface fleet, became targets that Allied forces hunted with growing effectiveness. Routes that had once been manageable were becoming treacherous. And in that tightening web of constraint, German naval planners began to look at what they actually had available, measuring capability, not against ideal purpose, but against immediate need. The Type X's size, which had always been both its strength and its complication, suddenly looked like something else entirely: space. The Type X had been engineered to carry a large number of mines across great distances, and that engineering had produced a submarine with a hull volume and a fuel capacity that dwarfed most other boats in the Kriegsmarine's inventory. Where a standard frontline U-boat was lean and purpose-built for the torpedo hunt, the Type X was comparatively cavernous. Its external mine shafts occupied the saddle tanks, but the interior of the pressure hull still held considerable space. Its range, measured in thousands of nautical miles, allowed it to reach theaters that smaller boats could only approach with careful fuel discipline. To a logistician staring at a map and a shrinking list of available vessels, those qualities were not irrelevant luxuries. They were answers to urgent questions. The shift did not happen all at once, and it did not represent a clean abandonment of the Type X's mine-laying mission. Rather, it emerged as an overlay missions that blended the boat's original role with secondary tasking, or patrols where the mine capacity was supplemented by cargo that would have seemed strange in the vessel's early service life. Fuel was among the most critical commodities. The Kriegsmarine's submarine arm depended on at-sea replenishment to extend the range of its frontline boats, and as dedicated submarine tankers, the so-called milk cows came under devastating Allied pressure. The burden of keeping operational boats fueled and supplied fell on whatever large, capable submarines remained available. The Type X, with its generous fuel reserves, was a natural candidate. A boat returning from a mine-laying patrol in distant waters might carry enough surplus diesel to replenish a smaller boat at sea, extending that boat's patrol without requiring a costly and dangerous return to port. Beyond fuel, the Type X began to move cargo of a different kind. Critical war materials, technical components, precision instruments, specialist equipment that could not be trusted to surface shipping in contested waters found their way into the holds and spaces of these large submarines. Germany's global strategic situation, particularly in relation to its Japanese allies, created demand for exactly the kind of long-range, discreet transport that the Type X could theoretically provide. The distances involved in reaching Japanese-controlled ports were extraordinary, stretching across tens of thousands of kilometers of ocean. Only a submarine with genuine long-range endurance could attempt such a voyage with any reasonable prospect of success. The Type X was not the only boat considered for these missions, but its characteristics placed it firmly in the category of vessels capable of even attempting them. Personnel movements were another dimension of this evolving role. Officers, technical specialists, diplomatic personnel, and intelligence figures who needed to move between Germany and distant theaters without exposure to Allied interdiction required transport that surface vessels could no longer safely provide. A submarine offered concealment. By definition, it could be anywhere and nowhere, slipping beneath the surface of international waters while the war raged above. The Type X, with its relatively more habitable interior compared to the cramped confines of a frontline torpedo boat, was better suited to carrying passengers for extended periods. Not comfortable, by any measure, life aboard any submarine remained an exercise in physical and psychological endurance, but at least possible in a way that a smaller, more densely packed boat made almost impractical. What these secondary missions reveal, when laid out plainly, is something more significant than a practical, logistical adjustment. They reveal the widening gap between Germany's strategic ambitions and its actual material capacity. A navy with abundant, purpose-built supply submarines and surface replenishment vessels does not need to redirect its specialist mine layers into cargo runs. A strategic situation with secure surface routes and reliable Allied logistics does not demand that rare, complex, long-range boats be improvised into general-purpose transports. Each time a Type X was tasked with something other than mine-laying, it was a quiet admission recorded in operational logs and fleet dispositions that the Kriegsmarine was stretching thinner than its original wartime calculations had assumed. The human dimension of this shift was not lost on the men who served in these boats, a crew trained to think of themselves as a precision weapon, men who had rehearsed the careful navigation of defended shipping lanes, the silent counting of mine deployments in darkness, the particular discipline of the invisible kill, now found themselves recategorized, at least for stretches of their operational service, as haulers. The professional identity of a mine-laying submariner was a specific thing, built through months of training and sustained by a sense of specialized purpose. Being told that your boat was now carrying machine parts or aviation fuel across thousands of miles of ocean was not, emotionally speaking, a neutral reassignment. Some crews adapted with the stoic practicality that naval service demands. Others felt the shift more keenly, understanding instinctively what it meant when rare, expensive submarines were pulled from their designed mission to patch holes in a supply system that was slowly coming apart. The operational challenges of these supply missions were also considerable in their own right. Navigating a very large submarine across extraordinary distances, through waters increasingly monitored by Allied aircraft and surface patrols, required a different calculus of risk than a mine-laying approach to a specific coastal target. The Type X's size, which made it capable of carrying significant cargo, also made it a larger sonar and radar return, a more visible presence at the surface during the brief but essential periods when the boat needed to run on its diesel engines and recharge its batteries. Every hour spent on the surface during a supply run across contested ocean was an hour of vulnerability that could not be entirely managed away by careful timing or clever routing. There was also the matter of opportunity cost, which German planners were not unaware of. Every Type X committed to a supply role was a Type X not laying mines. The mine-laying mission had produced genuine strategic returns, disrupted convoy routes, damaged vessels, massive Allied minesweeping expenditure, the psychological weight of waters that could not be trusted. Those returns required the boats actually doing the work. A Type X motoring across the South Atlantic with diesel drums in its saddle tank spaces was not threatening the approaches to Liverpool or the convoy corridors of the North Sea. The Kriegsmarine's mine-laying capacity was already limited by the small number of Type X boats ever commissioned. Diverting even one of them for extended periods represented a meaningful reduction in that capacity, and the trade-off was not always clean or comfortable in the planning rooms of German naval headquarters. Yet the planners made the calculations and issued the orders, because they had to. The war was generating demands that outran tidy doctrinal boundaries. The Type X had been built with a specific purpose in mind, but wars are notoriously indifferent to the intentions of engineers. They find the capability in a hull and put it to work, regardless of what the design specification originally said. The boats were available, the need was real. The orders were written, and the crews prepared for voyages that would have seemed improbable when the Type X had first put to sea as a minelayer in the early years of the conflict. What the secondary role chapter of the Type X's story ultimately illustrates is a pattern visible across the entire German war effort. In its middle and later years, the steady compression of specialization under the weight of strategic necessity. Purpose-built weapons and purpose-built platforms were asked to be something other than what they were designed to be, because the carefully constructed system of specialist assets that German planning had assumed was no longer intact. The Type X had been conceived as a precision instrument of area denial, a boat that could quietly contaminate entire shipping corridors with invisible, patient weapons. It remained capable of that mission. But it was also, by the midpoint of the war, a large, capable, long-range submarine, operating in a strategic environment where large, capable, and long-range were qualities in short supply. That combination meant the boat could never quite belong entirely to any single mission again. It existed at the intersection of what it had been built to do and what the war now required of it, and that intersection, cramped and uncomfortable, was where its remaining service would unfold. By the middle years of the war, the ocean had become a different place. The same waters that had once allowed U-boats to move with something approaching impunity were now threaded with listening arrays, swept by aircraft radar, and patrolled by escort vessels whose crews were growing steadily more capable and more ruthless in their pursuit. For the Type X boats, already large and deliberately ungainly by the standards of the U-boat fleet, this transformation was not an abstract strategic problem. It was something the men aboard felt in their bones every time they surfaced to charge batteries or received a signal reporting another boat that had failed to return. The war was changing around them, and the machines they sailed had been built for a different version of it. The question confronting the Kriegsmarine's engineers and planners was whether those machines could be changed quickly enough to keep pace. The most immediate and visible response to the shifting threat environment came in the form of anti-aircraft armament. In the early years of the war, a surfaced U-boat encountering an Allied aircraft had a reasonable chance of diving to safety before an attack could be pressed home. Aircraft patrols were sparse, coordination between air and sea forces was inconsistent, and the weapons available to patrol aircraft were not always well suited to attacking a fast-diving submarine. By the middle years of the war, all of those conditions had reversed. Allied patrol aircraft now carried increasingly capable weapons, flew in greater numbers over the convoy routes, and were beginning to benefit from radar systems that could detect a surface submarine at ranges that gave the crew almost no warning at all. The instinct in the Kriegsmarine was to fight back rather than simply run, and the Type X boats were progressively fitted with heavier anti-aircraft guns on their conning towers and wintergarden platforms. Additional twin and quad-mounted automatic cannon were worked into the boat's upper structures, giving them a greater capacity to put up a defensive barrage during the critical seconds of an aircraft attack. The men who served on those guns understood they were trading one risk for another. Standing exposed on a heaving deck with aircraft closing meant accepting that some of them would not make it back below. The anti-aircraft upgrades were not without cost to the boats themselves. Every additional mount, every added ammunition locker, every reinforced platform bracket represented weight and drag, added to a hull that had never been designed with midlife modification in mind. The Type X was already a large, heavy vessel, and additional topside structure changed its handling characteristics in ways that the original architects had not anticipated. Trim calculations that had been worked out during sea trials now had to be revised. The extra topside weight shifted the center of gravity in ways that made the boat less comfortable in heavy Atlantic swells and marginally less predictable during emergency dives. These were not catastrophic changes, but in a vessel where every second of diving time and every degree of trim angle carried operational significance, they mattered. The engineers who performed the modifications did what they could to compensate, redistributing ballast and adjusting flooding sequences, but there were limits to how much could be fixed from the outside once the fundamental design had been frozen. Alongside the visible changes to armament came quieter but equally significant improvements to the boat's detection equipment. The early U-boats had relied largely on human senses, the lookout's eyes, the hydrophone operator's ears, and on a general situational awareness that was always incomplete. By the middle of the war, electronic warfare had become central to submarine survival in ways that would have seemed almost theoretical to the officers who had first commissioned the Type X's design. Search receivers capable of detecting the radar emissions of patrolling aircraft were fitted to the boats, giving the crew at least some warning that an aircraft was actively searching nearby. These devices became a form of nervous system for the surface submarine, translating the invisible electromagnetic environment into audible signals that could prompt an emergency dive before the aircraft itself ever came within sight. Crews learned to interpret those signals with the same focused attention they gave to the hydrophone. A change in tone, a shift in signal strength, a pattern of sweeps that suggested the aircraft had altered course toward them. All of it had to be read quickly and read correctly. The hydrophone equipment itself was refined and improved during the mid-war period. Earlier systems had been effective but limited in their ability to discriminate between different sound sources or to provide reliable bearing information in complex acoustic environments. Upgraded arrays gave operators a more detailed acoustic picture of the waters around them, improving their ability to detect approaching surface vessels and to make sense of the overlapping sounds that filled a busy convoy route. For the Type X, which spent much of its operational time in shallower coastal waters where acoustic conditions were particularly complex, these improvements were directly relevant to survival. A mine-laying mission required extended periods of slow, controlled movement close to enemy shipping lanes, and the ability to hear what was approaching from beyond visual range was often the difference between a completed mission and one that ended in a depth charge pattern. Diving protocols were another area that evolved in direct response to wartime experience. The time it took a submarine to go from surface to safe depth was a quantity that could be measured in seconds, and every second counted when an aircraft attack developed without warning. Crews aboard the Type X boats drilled on emergency dives with an intensity that bordered on obsession, reducing their times through repetition until the sequence became something close to reflex. Flooding valves were adjusted, hatch sequences were modified, and the precise choreography of who went below first and in what order was rehearsed until every man could perform it in darkness and in fear. But there was an irreducible physical constraint that no amount of training could entirely overcome. The Type X was simply bigger than a standard combat U-boat. It had more volume to flood, more surface area exposed during the dive, and a larger silhouette visible from the air during those agonizing seconds when the hull was neither fully surfaced nor safely submerged. The boat's designers had known this when they drew the original plans. By the middle of the war, the crews lived with it as a daily fact. The tension between size and survivability ran through every conversation about the Type X's mid-war situation. Size had been the entire point of the design. A large hull was what allowed the boat to carry the external mine shafts, the fuel reserves for extended range, the supplies for a long patrol. All of those advantages remained real. But size also meant a larger radar cross-section, a deeper thermal displacement in the water, a longer diving time, and a wake that was marginally more visible from the air on a calm day. There was no engineering solution that could make the Type X smaller without making it something other than what it was. The men who served on it understood this. They were not sailing a fleet boat designed for speed and flexibility. They were sailing a working vessel built for a specific and demanding task. And surviving in a war that had outgrown the conditions that task had been designed for required a kind of disciplined pragmatism that went beyond technical adaptation. Some of the most important adaptations were tactical rather than mechanical. As Allied air coverage over the Atlantic expanded, Type X commanders developed a more cautious approach to surface transits. Where an earlier patrol might have spent extended periods on the surface to make best speed between waypoints, later patrols treated the surface as a place of danger, to be crossed quickly and abandoned at the first sign of threat. Boats moved at night and dived at the first hint of dawn, sacrificing battery endurance to avoid exposure. The rhythm of a patrol changed longer submerged periods, more conservative use of the schnorchel once that device became available, and a heightened reliance on passive listening rather than active movement. These changes imposed real costs in terms of patrol duration and the time available to conduct mine-laying operations, but they represented a rational response to a threat environment that left little margin for error. The introduction of the schnorchel, the tube that allowed a submerged submarine to run its diesel engines and recharge batteries without surfacing, came too late in the war to transform the Type X's operational situation, but it offered a partial answer to the problem of battery endurance during long submerged transits. For a boat as large as the Type X, which consumed battery power at a rate proportional to its displacement, the ability to recharge while submerged was genuinely significant. But the schnorchel had its own vulnerabilities. Its head valve could ice over in cold northern waters, cutting air supply to the engines with potentially catastrophic results. The device created a radar reflection and a telltale disturbance at the surface that alert aircraft crews were learning to recognize. And operating on schnorchel required a level of sustained concentration from the engineering crew that was exhausting over long periods. It was a solution, but an imperfect one which described most of the adaptations the Type X underwent during the middle years of the war. What the record of these modifications ultimately reveals is not a story of successful modernization, but of incremental resistance against a deteriorating situation. The men in the engineering bureaus were not slow or careless. They understood the problems clearly and worked to address them with the resources available. But those resources were finite, and the war was generating new threats faster than any established design could absorb them. Each addition to the Type X, each new gun mount, each improved receiver, each refined diving protocol represented a genuine improvement over what had come before. Taken together, they represented a fleet of boats that were meaningfully more capable of surviving into the middle years of the war than they would have been without modification. But they did not represent a solution to the fundamental challenge that size posed in an era of expanding Allied air and surface coverage. There is something particular about watching a carefully engineered system strain against the limits of what engineering can do. The Type X had been built to solve a specific problem, and it had solved that problem well. The modifications of the mid-war years were an attempt to keep that solution relevant in a world that had moved on from the question it was designed to answer. The crews who sailed those adapted boats were not naive about what they faced. They had seen enough patrols, heard enough signals, and lost enough friends to understand that the balance had shifted. What kept them at their stations was not the belief that the machinery would protect them, but something harder and quieter. The habit of professionalism in the face of odds that the instruments could measure but could not improve. There is a particular kind of grief that runs through a navy when it loses a submarine. A surface ship sinks in full view, fire, debris, the visible wound of it recorded by witnesses on both sides of the fight. But a submarine simply does not come back. The harbour waits, the signals go unanswered. And somewhere beneath a sea that reveals nothing, a crew of men and the machine they served are gone. Without ceremony, without a grave, anyone can visit. For the Kriegsmarine's Type X fleet, that silence came early, and it came repeatedly, each loss cutting deeper into a class that had never been built in large numbers to begin with. The Type X boats were not expendable assets that could be replaced from an overflowing production line. They were rare, complex, purpose-built vessels, and every one that failed to return home tightened the noose around a mine-laying capability that Germany was already struggling to sustain. Understanding what the losses meant requires understanding not just how the boats were lost, but what each loss took with it: the trained men, the accumulated experience, and the irreplaceable strategic weight of a hull that no shipyard could quickly rebuild. The Type X program had never been large. Germany constructed only 8 boats in the class, and from the earliest operational patrols it was apparent that the margin for attrition was desperately thin. This was not a fleet that could absorb punishment the way the broader U-boat arm could, drawing on hundreds of Type 7 hulls rolling steadily out of German yards. Each Type X represented an enormous investment of steel, specialist engineering, and months of skilled labour. The construction of a single boat consumed resources that in other configurations might have produced several smaller submarines. When one was lost, there was no replacement waiting in a fitting-out berth, no sister hull weeks away from completion that could fill the operational gap. The Kriegsmarine planners who drew up mine-laying assignments were acutely aware that the margin between a functional mine-laying force and no mine-laying force at all was measured in single digits, and those digits were shrinking. The first losses revealed something important about the environment in which the Type X was now operating. These were not boats caught by lucky chance, a patrol aircraft stumbling across a surfaced U-boat in a quiet stretch of ocean. By the period in which the Type X fleet began suffering sustained attrition, Allied anti-submarine capabilities had matured considerably. Radar fitted to maritime patrol aircraft meant that the long Atlantic night, which had once provided some cover to U-boats running on the surface to recharge their batteries, was no longer safe. Improved depth charge patterns, better sonar, and coordinated hunter-killer groups operating around convoys created an environment in which a large submarine and the Type X, at roughly 90 meters in length and displacing more than 2,000 tons when submerged, was a large submarine, was at a structural disadvantage. Its size, which gave it range, mine capacity, and crew endurance, also made it a more detectable target, a larger return on a sonar screen, a harder hull to maneuver quickly when evasion was required. What the records of individual losses share is a pattern that becomes grimly familiar across the middle years of the war. A boat departs on patrol, moves into contested waters, and at some point ceases to communicate. The subsequent reconstruction of what happened draws on whatever fragmentary evidence survives. Allied aircraft logs, escort vessel reports, the testimony of other U-boat commanders who passed through the same waters and noted increased patrol activity. In most cases, no one aboard survived to describe the final sequence of events. The boats went down with their full complements, taking with them crews that numbered in the 50s and 60s, men who had trained together through the Baltic winters, who had served multiple patrols, who carried inside them the hardest-won kind of knowledge, the knowledge of how to keep a mine-laying submarine alive in waters that were trying to kill it. That institutional memory went to the bottom with the boat, and it could not be recovered or transferred to the next crew. The human arithmetic of these losses is worth pausing on. A single Type X carried a crew roughly half again, as large as a standard Type 7, a reflection of the additional demands of managing the external mine shafts, the greater mechanical complexity, and the sustained endurance operations the boat was designed to conduct. When a Type 7 was lost, the Kriegsmarine mourned a crew of perhaps 45 to 50 men. When a Type X went down, the toll was commensurately heavier. The training pipeline that fed replacements into the U-boat arm was under pressure across all vessel classes by this point in the war, but the Type X's specialist requirements meant that even if the hull could theoretically be replaced, the crew for it could not simply be pulled from a general pool. Mine-laying operations demanded particular expertise in navigation, in the operation of the shaft mechanisms, in the coordination of precise positioning under conditions of near-total sensory deprivation at depth. Building that expertise took months, losing it took seconds. Morale across the surviving crews absorbed each loss in ways that were not always visible from the outside. The U-boat arm had maintained, through the early and middle years of the war, a culture of institutional confidence, the belief, however battered, that skill and discipline and the quality of German submarine engineering gave a crew a fighting chance. As losses mounted and the men who returned from patrols brought back accounts of increasingly relentless Allied pressure, that confidence curdled slowly into something more fatalistic. The crews of the remaining Type X boats were not broken men, but they were men who could calculate odds. They knew how many of their class had been built, and they could count how many were still operational. They knew that the waters into which their next orders would send them had recently swallowed their comrades. Professional discipline held, because it had been drilled too deep to simply dissolve, but the weight of what was known pressed on every patrol briefing, every departure from port. Operational planning at the command level reflected the new arithmetic with increasing candor. The Kriegsmarine's mine-laying ambitions had to be scaled against the reality of what remained. Missions that might once have been assigned to a single Type X were now assessed against the question of whether the boat could reasonably be expected to return. This was not defeatism, it was the cold logic of a force operating at the edge of its reserves. Patrol routes were reconsidered, target areas re-evaluated for the intensity of Allied countermeasures in their vicinity. The aggressive forward positioning that had characterized early Type X operations, moving close to heavily defended British and American ports to lay mines in the approaches, became progressively harder to justify when the boats conducting those missions were numbered on one hand. Distance, caution, and reduced operational tempo became, almost by default, the new doctrine, not because anyone had formally decided this, but because the losses had decided it for them. Germany's industrial machine, already straining under the demands of fighting a multi-front war, could not easily compensate for the shrinking Type X fleet. The yards that had built the class were occupied with other priorities: the continued production of Type Vs and Type 9s, repair work on damaged vessels, and the competing demands of the surface fleet and the Army's requirements for armoured vehicles and artillery. A decision to authorize new Type X construction would have required diverting materials and skilled labor from programs that the overall war effort treated as more urgently essential. The specialized knowledge required to fabricate the external mine shaft assemblies, the saddle tank structures, and the precision mechanisms that made the mine-laying system function was not something that could be improvised quickly or transferred to an unfamiliar workforce. In practical terms, the losses in the Type X fleet were permanent. What was gone was gone. The boats that were damaged but not destroyed presented their own category of strategic cost. A Type X that returned to port with significant hull damage, mechanical failures in the mine-laying apparatus, or the loss of key crew members to wounds required months of repair before it could return to operational status. Those months were not free. They consumed berth space, dockyard labor, and spare components that were themselves increasingly difficult to source. As the Allied strategic bombing campaign began to disrupt German industrial supply chains, A boat sitting in a repair dock was, for the duration of its repair, as absent from operational calculations as a boat at the bottom of the Atlantic. The Kriegsmarine was not losing only what the sea took, it was losing weeks and months of operational availability through the cascade of maintenance demands that intensified as the boats aged and their equipment accumulated the stress of hard service. What each loss revealed, in a way that individual patrols could not, was the structural fragility that had always been implicit in building a specialized capability in such small numbers. The Type X had been conceived as a force multiplier, a vessel whose mines would deny waters far from the scene of laying, generating ongoing disruption long after the boat itself had returned to safety. That concept required surviving boats to generate ongoing missions. As the fleet contracted, the multiplier effect contracted with it. A mine laid in a harbour approach continued to threaten traffic for as long as it remained unswept. But a mine that was never laid because the boat that would have carried it was at the bottom or in dry dock threatened nothing. The strategic promise of the Type X was inseparable from the physical existence of the Type X, and that physical existence was being steadily reduced. By the time the fleet had absorbed its worst losses, the Type X's role in the Kriegsmarine's operational thinking had been forced through a fundamental recalibration. The boats that remained were assets to be preserved as much as deployed, precious enough that the calculus of any mission had to weigh what would be gained if it succeeded against what would be lost if it did not. That calculus had not existed in the same form during the early patrols, when the boats were newer, the crews were fresher, and the Allied response had not yet found its full weight. What the losses had done, in the end, was transform the Type X from an offensive weapon into a diminishing one, still capable, still crewed by men of extraordinary competence and will, but operating in conditions that their boat had not been designed to survive indefinitely. The sea was patient, and it was thorough, and the harbour berths that stayed empty were the most honest accounting of what that patience and thoroughness had cost. There is a moment in any long campaign when the mathematics of war quietly change, not with a single dramatic stroke, but through the accumulation of 100 smaller shifts, a new piece of technology here, a revised convoy route there, an intercepted signal decoded in a damp room far from the ocean. For Germany's U-boat fleet, that moment crystallized across the spring and summer of 1943. What had once been a campaign of lethal confidence became something altogether different, a fight for survival, conducted by men who could feel the odds moving against them, even if they could not name the precise machinery driving that change. For the Type X minelayers, already a small and specialized fleet operating at the margins of Kriegsmarine doctrine, the shift was both slower in its arrival and more complete in its consequences. They had never hunted convoys in the way the standard attack boats did, but they had moved through contested waters with a degree of freedom that the new reality of the Atlantic would no longer permit. The broader collapse of German fortunes at sea in 1943 did not happen in isolation. It was the product of years of Allied investment in countermeasures that had finally, collectively reached maturity. Centimetric radar, fitted to long-range patrol aircraft, was perhaps the single most consequential development. Where earlier radar sets had given U-boats enough warning to crash dive before an aircraft reached attack range, the new centimetric sets operated on wavelengths that Germany's U-boat detection receivers simply could not pick up. Boats that had grown accustomed to surfacing at night to recharge batteries, a ritual as fundamental to submarine life as breathing, were now being caught without warning, held in the beam of a searchlight and bracketed by depth charges before the watch officer could even shout the order to dive. The ocean that had once offered cover in darkness offered it no longer. Simultaneously, the Allied convoy escort system underwent a transformation that compounded the crisis for every boat operating in the Atlantic. Dedicated escort carrier groups, small carriers attached to convoy routes, specifically to close the air gap over the mid-Atlantic that land-based aircraft had never been able to reach, removed the last refuge U-boats had relied upon. The gap had been known among German submariners as a region of relative safety, a stretch of open water where a boat could operate on the surface and breathe. By the middle of 1943, that gap had closed. Aircraft were now overhead for the entirety of a convoy's crossing, coordinated with surface escorts through improved communications and supported by direction-finding technology that could locate a transmitting U-boat within minutes of its making contact. The wolf pack tactics that had brought such success in the earlier years of the war required boats to surface and communication had become lethal. Behind all of this, invisible to the men dying in the Atlantic but shaping almost every aspect of their fate, was the intelligence war. The breaking of German naval cipher communications, the product of painstaking work by Allied codebreakers drawing on intercepted signals, captured equipment, and the kind of sustained institutional effort that rarely makes headlines, meant that convoy routings could be adjusted away from known U-boat patrol areas, and that Allied forces could be directed toward boats whose positions were already known. The Kriegsmarine was, at critical junctures, fighting an enemy that knew where it was. The wolf packs were being vectored onto convoys that had already been warned, and the hunters were being hunted by forces that had been told precisely where to look. For any submarine operating in this environment, the margin between mission and catastrophe had narrowed to almost nothing. The Type X boats had never been conceived as frontline combat vessels in the way that the attack submarines were. Their missions required them to approach enemy coastlines or shipping lanes covertly, release their mines, and withdraw without being detected, a task demanding patience and precise navigation more than aggressive positioning. But the same environmental deterioration that was destroying the attack fleet was closing the operating space the minelayers depended on equally. The approaches to British ports, the lanes around the Scottish coast, the waters off the American eastern seaboard, all of the areas where mine-laying operations carried the most strategic value, were now under increasingly effective aerial surveillance. Reaching those waters had once been a matter of careful seamanship and good fortune. By the latter half of 1943, it required the traversal of an ocean that was actively trying to kill you at every stage of the transit. For the Type X crews, this transformation manifested in ways that were both statistical and deeply personal. The transit time required to reach a viable mining area had always been considerable. These were large, not especially fast submarines, and their routes from Norwegian or German bases to productive targets were long. Now, those routes were contested at every point. Boats that had previously made their passages submerged during daylight and surfaced at night for propulsion now found that even night surfacing carried acute risk. The decision of when to surface, how long to remain up, and when to dive again became a constant calculation of competing dangers, the need to make speed toward a target area versus the near certainty that prolonged surface running would eventually attract an aircraft. The battery endurance that shaped every submarine's rhythm became an oppressive constraint, a clock counting down in the background of every decision made aboard. The Kriegsmarine's operational planning began to reflect, if not yet openly acknowledge, these new realities. Orders to the Type X boats underwent a gradual but unmistakable evolution. Areas that had previously been designated as primary mining targets were reclassified as high-risk approach zones. Transit routes were lengthened to avoid known patrol aircraft coverage, adding days to journeys that were already long. The operational windows during which mine laying could be conducted based on tide, visibility, and the position of patrol vessels became more restrictive as Allied surface coverage in nearshore waters intensified. What had been a fluid, opportunistic operating style was being compressed into an ever narrower set of conditions that had to align almost perfectly before a mission could proceed. The difference between a mine-laying operation conducted in 1941 and one attempted in late 1943 was not merely tactical, it was categorical. Morale aboard the boats reflected this compression in ways that no official document fully captures, but that veterans' accounts convey with quiet clarity. The men of the Type X crews had always understood that their work was dangerous and its results invisible. They laid their mines, withdrew, and never saw what those weapons did. That psychological distance had always been part of the particular character of mine-laying service. But in the earlier years, there had been the compensating knowledge that the mission itself was achievable, that the boat would reach its assigned area, perform its task, and return. As 1943 progressed, that confidence became harder to sustain. Every patrol began with the awareness that the conditions they were sailing into were objectively more hostile than those their predecessors had faced. The professional discipline of trained submariners held, but it held against a current that was growing stronger. Doctrine, that formal architecture of how a navy expects its weapons to be used, had to bend under this pressure. Dönitz and the Kriegsmarine High Command were confronted with a fundamental dilemma that had no clean solution. The Type X boats represented a rare and strategically valuable capability: the ability to lay large numbers of mines covertly in waters that surface minelayers could never reach. Abandoning their use entirely would concede an entire dimension of the naval campaign, but continuing to deploy them on missions that carried dramatically higher losses for dramatically lower expected results was a form of institutional hemorrhage the Kriegsmarine could not sustain. The compromise that emerged was, in practice, a more conservative operational tempo. Fewer patrols, more carefully selected targets, longer intervals between deployments, and a heightened emphasis on the survival of the boat over the completion of an ambitious mining pattern. Caution, which had once been a characteristic of execution, became a characteristic of strategy. The physical demands on the surviving boats intensified in parallel with the operational demands on their crews. Each Type X that put to sea in this period was, in a sense, irreplaceable. The shipyard capacity that had built them was now directed toward other priorities, and the production of new mine-laying submarines of comparable capability was not forthcoming at any scale that could offset losses. Every boat that returned from a patrol represented a continuation of capability that could not be regenerated if lost. This awareness filtered through the maintenance culture aboard and in the supporting infrastructure of the ports. Equipment that might previously have been considered serviceable was now subject to more rigorous inspection. Defects that might once have been tolerated for a short patrol were repaired before sailing. The boats were being treated with the care of things that were running out. Allied analysts tracking the U-boat campaign registered the shift in Type X activity, even if the precise intelligence on individual boats was sometimes incomplete. The reduction in mine-laying incidents in certain previously active areas was itself informative, a silence that spoke of operational constraint. Mine-sweeping efforts in some regions could be cautiously reduced, allowing those resources to be redeployed elsewhere. The areas where the Type X had previously forced significant disruption to shipping were, gradually and unevenly, becoming more manageable. This did not mean the threat had ended. A single Type X laying a successful field in a critical shipping lane could still impose weeks of disruption and the loss of vessels far beyond its own cost. But the frequency of successful operations was declining, and the cost of each attempt was rising. What 1943 and its aftermath established, then, was not the destruction of the Type X as a class that would come later, and by more direct means. What it established was the erosion of the conditions under which the Type X had been designed to operate. The boat had been conceived for a particular kind of war, one in which a capable, long-range submarine could transit contested waters with acceptable risk, conduct a precise and covert operation, and return to fight again. That war was ending. What was replacing it was something the designers in their drawing offices and the admirals in their planning rooms had not fully anticipated: an ocean in which the act of being at sea for a German submarine of any type had become the primary danger. The Type X had not yet fought its last battle, but the shape of the battles still to come had already been determined by forces its crew could not control, in rooms they would never enter, by men who did not know their names. By the later years of the war, the rhythm of departure had changed. There was a time when a U-boat leaving port drew something close to ceremony crowds at the quayside, officers on the bridge, the quiet confidence of a weapon heading out to do what it had been built to do. By the closing stages of the conflict, departure was a quieter and more somber affair. The men who walked the gangways and sealed the hatches behind them understood, with a clarity that no amount of official optimism could obscure, that the odds had shifted in a fundamental and perhaps irreversible way. The Allied net had tightened aircraft over waters that had once been dark and empty, escort groups that hunted with a patience and precision the early years had never threatened. For the surviving Type X boats, each order to sail was an order issued into a world that had spent years learning exactly how to kill them. The boats themselves carried the marks of that learning, hulls that had been repaired once, twice, sometimes more. Equipment upgraded in the yards during layovers that grew longer as the industrial strain on Germany deepened. The additional anti-aircraft guns fitted along the conning towers gave the boats a bristling, defensive silhouette that spoke to where the real danger now came from, not from beneath the surface, but from above it. Every modification told the same story. The Type X had been designed for a war in which it could approach enemy waters with a degree of operational freedom, lay its mines, and withdraw before the response could organize itself. That war was gone. What remained required the same boats, the same men, and very different expectations. The crews who sailed on these final patrols were not the same men who had sailed the first ones, though some veterans remained. The losses of previous years had drawn deeply on the pool of experienced submariners, and the Type X boats now sailed with men who had trained in a Kriegsmarine that was increasingly rationing everything fuel, parts, and time. Training cycles that had once stretched across many months in the Baltic had been compressed. The experienced petty officers and ratings who formed the institutional backbone of any warship were thinner on the ground, and yet the discipline held. There is something in naval culture, the intimacy of a confined hull, the shared dependence on every man performing his task that sustains professional function long after the strategic picture has turned dark. The boats sailed because the orders came, and the men obeyed because training and duty had made obedience almost indistinguishable from instinct. What those men carried with them into the deep was not ignorance of the situation. Letters from home described bombed cities, rationed food, and an official narrative that no longer matched anything visible from a kitchen window. Men aboard the boats spoke in careful terms, when they spoke at all, about what they understood the war to be becoming. The political culture of the Third Reich discouraged candor, and the Kriegsmarine's own codes of conduct pressed hard against open defeatism. But in the close and unavoidable intimacy of a submarine where a man's bunk was separated from the next man's by inches, where exhaustion and fear shared the same air, the understanding was there, unspoken and heavy. They were sailing, many of them, not because they believed the war could be turned, but because turning back was not a choice the institution made available to them. The operational orders for these final patrols reflected a Kriegsmarine grappling with strategic bankruptcy dressed as strategy. The ambitions remained on paper mining approaches, disrupting convoy routes, threatening harbour mouths along the British coast and in Atlantic waters. But the planning now had to account for a threat environment so saturated with Allied air and surface assets that route planning itself had become an exercise in threading needles. The long transit through the Bay of Biscay, once a route crossed with reasonable confidence, if not comfort, had become a gauntlet. Aircraft equipped with improved radar could detect a surface submarine at distances that gave the U-boat almost no reaction time. The Type X, large and slow to dive, was acutely vulnerable during those transits. Commanders knew this. They crossed anyway. Submerged running consumed the boat's batteries at a rate that required surfacing in darkness to recharge a dangerous routine that had once been managed but could now mean exposure to the very patrols the darkness was meant to hide them from. The Schnorchel, fitted to some boats in the later years, allowed diesels to be run at shallow depth without fully surfacing, a partial solution that reduced the exposure window but introduced its own difficulties. The device was noisy internally. It produced a small radar return, and running submerged at depth for extended periods placed its own kind of strain on men who needed air and sleep, and some faint sense that the ocean around them was not entirely hostile. The technology helped. It did not transform the calculus. When the surviving Type X boats reached their operational areas, the approaches to British ports, the mouth of the Thames estuary, corridors through which convoys still moved, the mine-laying procedure itself remained as it had always been. Slow, precise, and conducted with care that the weapon required regardless of the condition of the men deploying it. The external mine shafts built into the saddle tanks had to be worked through a sequence that demanded attention and coordination at the moment when the crew was most exhausted from the transit. There was no cutting corners with mines. A mishandled mine did not merely fail, it ended the boat and everyone aboard it. The professionalism was not optional. The targets these last patrols sought to reach were not chosen carelessly. The Kriegsmarine still possessed enough intelligence and operational logic to identify corridors and anchorages where successfully laid mines could cause meaningful disruption. Allied minesweeping had become formidable, but no minesweeping operation was instant, and a shipping lane forced closed even for days imposed costs that accumulated. The Type X boats, in their final missions, were not sailing into the Atlantic on hopeless gestures. They were attempting, within a framework of genuine operational thinking, to continue doing what they had been built to do. The distance between genuine strategic effect and institutional inertia had simply narrowed to a point where it was almost impossible to distinguish between them from the inside. The physical conditions aboard during these final patrols added their own weight to everything else. Boats that had been at sea for weeks carried the smell and texture of that time in every surface. Condensation ran down the bulkheads. Food that had started the patrol fresh had long since given way to preserved stores. Sleep came in fragments, interrupted by watch rotations and the sudden calls to action stations that frayed the nervous system over days and weeks into something raw and unreliable. Officers monitored their men with as much attention as they gave to their instruments, watching for the particular kind of exhaustion that goes past tiredness into a dimming of judgment. The human machine that ran a submarine was as subject to wear as any of the mechanical ones, and in these later patrols there was less margin to absorb that wear. Commanders on these final patrols occupied a position that required a particular kind of psychological endurance. They held the responsibility for the mission and for the men simultaneously, and these responsibilities increasingly pulled in opposite directions. A commander who pressed his boat into a heavily defended area to lay mines was fulfilling his orders and his professional purpose. A commander who brought his crew home was fulfilling something more personal and perhaps more human. The men who commanded the Type X boats in these last years were not, by and large, men who had been broken by the war. They were professionals operating inside a system that constrained every choice they made, and they navigated that constraint with the tools their training had given them, which meant they kept sailing. Some of these final patrols achieved their objectives. Mines were laid in waters they were intended for. Some found targets. The accounting of what each patrol cost versus what it delivered had become, by this stage, a calculation that leaned further and further toward cost. But the missions went out, and the reports came back where the boats came back, and the Kriegsmarine logged them in a ledger that was running out of entries. The Type had begun the war as one of the most carefully considered instruments in the German naval arsenal, a vessel built from hard experience and deliberate engineering to carry a precise and deadly weapon into waters where no surface vessel could survive. It was ending the war as a remnant of that original purpose, sustained by discipline and institutional momentum in roughly equal measure, sailing into an ocean. It no longer controlled toward targets, it could still sometimes reach. What those final patrols represent, held at the distance history allows, is something more complex than simple futility. They are evidence of what a naval institution does when the strategic framework it was built for has collapsed, but the institution itself has not. The men of the Type X boats in these last deployments were not sailing with optimism. They were sailing with training, with obligation, and with the particular stoic endurance that submarine service demanded of every man, regardless of what year the calendar read. The ocean offered no negotiation, no exceptions for difficult circumstances, and no credit for effort. It demanded competence, or it took lives. In the final patrols of the Type X, competence was still present, still practiced, still enough to bring some boats through waters that should, by every measure of the strategic situation, have swallowed them whole. By the spring of 1945, the war in Europe was collapsing inward. The fronts that had once stretched across continents were now compressing toward the German heartland, and with them came the unraveling of everything the Kriegsmarine had built across more than 5 years of relentless naval war. For the men still aboard the surviving Type X boats, the signals coming through on the wireless told a story that needed no translation. Cities were falling, armies were encircled. The Reich that had launched them into the deep with such calculated ambition was dissolving around the people who had believed in it, feared it, or simply served it because there was no other choice. In the final weeks, the question was no longer whether Germany would surrender, but what the men of the U-boat fleet would do in those last hours before it came. For some, the answer was obedience to the last order. For others, it was something older and more instinctive, a sailor's refusal to let his vessel fall into foreign hands. Grand Admiral Karl Dönitz, by that point carrying the impossible weight of leading what remained of the German state, issued orders that attempted to shape the end with something resembling discipline. Under the terms of the surrender that followed in early May of 1945, U-boat crews were instructed to surface, hoist a black flag or a white one, and await Allied escort to designated ports. The scuttling of vessels was explicitly forbidden under the surrender terms, yet the culture of the U-boat arm had never been one of simple compliance. The crews had spent years operating in an environment where independent judgment was not a luxury but a survival requirement. And now, that same instinct shaped how they responded to the order to simply hand over what they had bled for. Some obeyed, some did not. The result was a final act of the U-boat war played out not in combat, but in the quieter, grimmer theatre of ending. The operation the Allies mounted to deal with the surrendered submarines became known as Operation Deadlight. Its purpose was blunt: to dispose of the U-boats collected from German ports and surrender points before any question of redistribution or retention could complicate the post-war settlement. Hundreds of submarines were gathered from ports including Wilhelmshaven, Kiel, and Loch Eriboll on the northern Scottish coast, where convoys of grey hulls arrived in the final days of the war, their ensigns gone, their crews removed, their weapons rendered safe. The scale of the collection was extraordinary, a fleet assembled not for war but for destruction, a graveyard of iron waiting to be committed to deep water. For the Allied sailors tasked with towing these boats out to the designated disposal grounds northwest of Ireland, there was something unsettling about the work. These were machines built to kill, now silent and compliant, awaiting a fate their builders had never imagined. Among the submarines processed through these final accounting procedures were the surviving Type X boats, and their passage through the surrender machinery was in its own way a summary of everything the class had been. They were large, they were conspicuous, they stood apart from the mass of smaller attack submarines in the collection. Their distinctive twin-hull profiles and broad saddle tanks immediately identifiable to any naval officer who had spent the war studying recognition silhouettes. Where a standard ocean-going attack submarine might be lost in the crowd of similar hulls, the Type X could not hide. Even at the end, stripped of crew and purpose, these boats carried their identity in their very dimensions. Allied officers who walked their decks for the first time in peacetime found themselves aboard vessels that were simultaneously familiar in concept and alien in detail. Not all of the Type X boats reached Allied hands intact. In the chaos of the final weeks, at least some were scuttled by their crews in German ports or in the shallower waters of the Baltic, where the retreating Kriegsmarine enacted its own version of the accounting. The scuttlings were acts of institutional pride as much as tactical calculation. There was no enemy to deny access to. The war was over. Yet the act of opening the seacocks or setting charges in the engine spaces was a way of saying that the boat belonged to no one else, that it would not be studied, displayed, or sailed under another flag. Whether that sentiment was shared by every man aboard, or whether some simply followed orders they did not have the energy to question, is impossible to know now. What remains is the record of hulls on the bottom of German and Scandinavian waters, resting in the cold and the dark as they have rested ever since. For the boats that were surrendered intact, the Allied inspection process was thorough and methodical. Naval architects, intelligence officers, and submarine specialists went aboard with measuring tapes and notebooks, documenting every compartment. The external mine shafts built into the saddle tanks drew particular attention. Allied designers had long understood the theoretical advantages of carrying mines outside the pressure hull, but seeing the system realized at full scale, the shafts, the release mechanisms, the capacity figures gave them something to measure their own assumptions against. What struck the inspectors most was not that the system was revolutionary, but that it was practical. The Type X had not been built on the edge of what engineering could achieve. It had been built carefully, with operational reality in mind, and the evidence of that pragmatism was visible in every detail. The inspection teams also noted the wear. These were not museum pieces. The surviving Type X boats showed the accumulated stress of years of hard service. Repairs welded over damage, equipment replaced with whatever had been available in increasingly strained shipyards. Improvisations that spoke to the resourcefulness of crews and maintenance crews working under constant pressure. The boats that had survived longest carried the most evidence of this cumulative strain. In a sense, what the Allies were inspecting was not only the design, but the biography of individual vessels, every patch and replacement, a chapter in the story of a war fought against mounting disadvantage. The intelligence value lay not just in what the engineers had designed, but in what the sailors had endured. The Allied assessment of the Type X as a class was measured and, in places, genuinely respectful. The mine-laying mission had been executed with a competence that the Allies were willing to acknowledge, even if acknowledging it meant recognizing how much disruption the boats had caused. The concept of the large, dedicated submarine mine layer was evaluated not as a German eccentricity, but as a legitimate answer to a real strategic problem. The external shaft system was assessed as an elegant solution that other navies had approached less successfully. The range and endurance figures were noted against the operational record. The conclusion was not that the Type X had been a perfect vessel, but that it had been a well-conceived one that had achieved genuine effect relative to its small numbers and the conditions under which it had operated. What the assessment also made clear, when placed honestly against the full record, was the arithmetic of loss. The Type X class had been produced in numbers that were always too small for the mission assigned to it. The boats that had been lost to Allied action, the patrols cut short, the months spent in secondary roles as supply vessels rather than mine layers, all of it had diluted the class's contribution below what its designers had intended. A handful of hulls spread across years of war, rotating through repairs and reassignment, could only do so much. The Allied analysts understood this, and so had the Kriegsmarine planners who had worked with the type throughout the war. The Type X had not failed at what it was designed to do. There had simply never been enough of them to do it at the scale that mattered. The men who had crewed these boats passed through prisoner of war processing and then, gradually, back into a Germany that no longer existed in any form they recognized. The Kriegsmarine was dissolved. The rank structures, the training pipelines, the culture of the U-boat arm, all of it formally ceased. Some of the officers who had commanded Type X boats would eventually contribute their recollections to post-war historical projects, their accounts forming part of the record that later historians and analysts would draw on. The enlisted men dispersed more quietly, back to cities and towns that had been bombed flat, carrying experiences that most of them found difficult to articulate to people who had not shared them. The particular knowledge of what it meant to lay mines in darkness and sail away without knowing what they had done that went with them into whatever lives they were able to build. Operation Deadlight itself unfolded over months rather than days. The towed submarines were brought out to the deep water grounds in groups, and their disposal was conducted with the workmanlike efficiency that characterized Allied naval operations by that stage of the war. Vessels that could be made seaworthy enough were towed. Those that could not were managed as best they could be. The deep water accepted them without ceremony. There were no speeches, no formal observances. The boats went down because that was what had been decided, and because the Allied navies had neither the space nor the political appetite to preserve them. For the Type X boats committed to those waters, the ending was as quiet and invisible as the work they had been built to do. They went into the deep, as they always had, and did not come back. What remained after the hulls were gone and the crews had scattered was the historical record partial, contested in places, but real. The Type X had been a weapon of genuine ingenuity, deployed in numbers that guaranteed it could never be decisive, against an opponent whose industrial and technological capacity it could slow but not stop. It had laid mines in waters that cost the Allies time and resources and ships. It had forced responses that tied up effort and men. It had done, in other words, what weapons of area denial are meant to do, not win battles in a single stroke, but complicate the enemy's world at a remove and at a cost that compounded over time. Whether that contribution tilted anything meaningfully in Germany's favour is a question the final ledger answers clearly enough. The war was lost, the boats were gone, but the fact of what they had done remained in the records of the Allied minesweeping operations, in the reports of ships damaged or sunk, in the rerouted convoys and the harbour closures and the months of careful, dangerous work that was required to undo what a small number of large submarines had quietly laid in the dark. When the last of the Type X boats fell silent, surrendered, scuttled, or consumed by the sea, the war moved on with the indifference that wars always reserve for the weapons they leave behind. There were no ceremonies for the mine-laying submarines, no victory parades or commemorative plaques mounted on harbour walls. What remained was something quieter, a body of operational knowledge, scattered across the desks of Allied naval analysts and the classified archives of post-war intelligence assessments, waiting to be read by the next generation of naval engineers who would build their own weapons for their own cold and uncertain world. The Type X had not won the war for Germany, it had not even come close, but in the deliberate, methodical way that military technology transfers its lessons from one era to the next, the boat's design philosophy would echo forward into decades that its builders never lived to see. That echo was not loud, but it was persistent, and it belonged to a class of submarine that had always worked best in silence. The Allied naval teams who inspected surviving Type X boats in the final weeks of the war found engineering that was, by any measure, ambitious. The external mineshaft arrangement built into the saddle tanks, that defining structural solution which had allowed the boat to carry far more mines than any internal configuration could accommodate, drew particular attention from British and American submarine architects. Here was a design that had solved a genuine engineering problem with a clarity that transcended the ideology of the Navy that produced it. The separation of the mine-carrying capacity from the pressure hull itself was noted as a principle worth preserving, one that had allowed the Type X to function as a true specialist rather than a compromised generalist. These analysts were not naive men. They understood that the Type X had been built in insufficient numbers, operated under increasingly impossible conditions, and had ultimately failed to alter the course of the war at sea. But failure in war and failure in engineering are different things, and what they were reading in the steel of those hulls was not defeat, it was a design argument that had been right about several things at once. The Cold War arrived before the ink was dry on the post-war assessments, and with it came a new and urgent demand for exactly the kind of capability the Type X had represented. The ability to deny sea lanes to an adversary without direct confrontation, to threaten maritime choke points from beneath the surface, to place weapons in the path of enemy shipping before a single shot had officially been fired. The Soviet Navy, which had inherited both captured German submarine technology and the institutional memory of its own wartime mine-laying operations, moved deliberately toward large submarine designs capable of deploying mines across vast oceanic distances. Western navies, watching this development with the careful attention that the Cold War demanded of everyone, drew their own conclusions about the continued strategic value of the mine-laying submarine as a class. The Type X had not invented this logic, but it had refined it, tested it under live operational conditions, and produced a record that Cold War planners could study with the advantage of hindsight. What made the Type X's post-war influence complicated was precisely what had made its wartime career complicated: the tension between specialization and adaptability. A submarine designed to do one thing extraordinarily well is only as valuable as the frequency with which that one thing is needed. The Type X had demonstrated that a dedicated mine layer could achieve genuine area denial effects that a conventional torpedo boat simply could not replicate the wrong hull shape to carry enough mines, the wrong internal arrangement to deploy them efficiently. But it had also demonstrated that a highly specialized vessel in a rapidly evolving war becomes a liability the moment its primary mission becomes secondary to survival. Cold War naval architects absorbed both lessons simultaneously, and the result was a generation of submarine designs that attempted to embed mine-laying capability within multi-role hulls rather than building boats that could do nothing else. The Type X's ghost was visible in those design choices not as a template to be copied, but as a cautionary argument about putting all of a Navy's specialized eggs in too few, too large, too visible baskets. The question of numbers had haunted the Type X from its first deployment, and it continued to haunt the strategic calculations that followed the war. Germany had commissioned only a handful of boats in the class, a number that was never sufficient to sustain continuous operations in more than one theatre simultaneously, let alone absorb attrition without critical effect. Post-war analysts returned to this point repeatedly, not to criticize decisions that had been made under the political and industrial pressures of a nation already stretched beyond its means, but to extract a principle that a specialized weapon system, however technically sound, multiplies its value geometrically with numbers and degrades catastrophically below a certain threshold of availability. The Type X had often been at or below that threshold. It had achieved real strategic effect, the minefields it laid, the shipping disrupted, the minesweeping resources diverted, the convoy routes rerouted, but it had achieved that effect inconsistently, in surges and pauses, determined more by operational attrition than by deliberate campaign design. This was the lesson that naval planners filed carefully away. Capability without sufficient mass is a promise the fleet cannot reliably keep. There is a kind of historical justice, quiet and without sentiment, in the fact that the Type X's legacy survived longer in the thinking of those who had fought against it than in the memory of the Navy that built it. The Kriegsmarine ceased to exist. Its institutional memory was dispersed, its officers absorbed into the new West German naval service or scattered into civilian life, its records captured and catalogued by the victors. But the Allied navies that had hunted the Type X swept the mines it had laid and studied its operational patterns through the long work of wartime intelligence. Those navies carried the Type X's lessons forward in their own doctrine, their own design bureaus, their own training for submarine and mine warfare operations. The boat had shaped its enemies as much as it had threatened them, which is perhaps the most durable form of influence a weapon system can achieve. The human dimension of the Type X's legacy is harder to measure and easier to overlook. The men who served aboard those boats, the officers who planned the mine-laying runs, the petty officers who tended the mineshaft mechanisms in the cold dark of the saddle tanks, the ratings who stood watch in waters where discovery meant death, left behind something more diffuse than technical drawings or operational reports. They left behind a template for a particular kind of professional endurance, the willingness to deliver a weapon and then withdraw, to accept that confirmation of success would come days or weeks later if it came at all, to make peace with the invisibility of their own work. That psychological discipline, the capacity to act consequentially without witnessing consequence, is not a quality that can be captured in a design specification. It belongs to the human part of the weapon system, and it was earned aboard the Type X boats through patrols that tested men in ways that conventional surface warfare, for all its violence, did not. It would be too generous to call the Type X a success, and too dismissive to call it a failure. The historical verdict that emerges from 70-plus years of post-war scholarship is more precise than either judgment. It was a correct answer to a genuine strategic problem, arrived at too slowly, built in too few numbers, and committed to a war whose pace and technological evolution outran the planning assumptions of its designers. The mines it laid caused real damage. The disruption it created to Allied shipping operations was disproportionate to its numbers, which is the best thing that can be said of any weapon that was always too rare. But the Type X never achieved the sustained, systemic effect that a larger fleet operating continuously might have delivered.